Hey guys, we are recording this session, and that should show you in front of your screen somewhere with a red dot showing that the session is actually being recorded. Can you please tell me that you can see the red dot? I hope you can. And this is something that you should be carefully watching, because if I somehow forget to record the session, then we have a problem. We don't have a video recording at the end of the session, which is not good. So we want to make sure that we do. So that's why I'm asking you. You can, by the way, keep your microphones open. There is no issue there as such. If you make too much noise, I will mute you. Don't worry about that. But keep your microphones open and just participate. I encourage participation. I encourage that you actually talk, that you share, that you listen, that you interact, that we do stuff. This is not just like a one-way street. We have a small group, so we like to have you interact with each other and me. And we have a variety of ways of doing things. And we have a program that we will follow through. We'll cover a bunch of different things as we go along. But my request to you is to actually participate. If I have you participate, I will enjoy. You will enjoy. If you don't participate, I will get bored. It looks like I'm talking to myself to this silly camera that I have. That's not what I want. So please participate. Please talk. You don't have to show your face. Not required. No, not at all. You can shut your camera down, like pretty much. My camera is far away from me. So I'm sitting in a studio. I have multiple cameras and lighting and all that. So I cannot put my camera on the webcam and shut it off. That's not what I can do, but you can. You don't have to keep the camera on, but it is nice to have it. If I can see you, I expect to be able to see what your reactions are. How are you responding? How are you receiving and giving me feedback? Because I really thrive on feedback. So a couple of things I want to check is, please tell me that you can see the red dot recording. Can you?
Yep.
Okay, good. Please keep an eye on this every time, because if I forget to have recording done, then we have a problem. So when we go through the program at the end of the sessions, we keep a video track of everything we do, and we produce video recordings that we'll accumulate right there. Recordings from the sessions. So this area is where we will store our recordings. As you can see, since 2016, I have been recording this, probably something like that. So there are a bunch of recordings already available. And this button here, I just created 2 days ago or something like that. I created a new button here that says Spring 2018, and it doesn't have any recordings right here. It doesn't have because we haven't had a session. But now the session is started. So we just started that. And what I would like to tell you is, this is the place where you will find a session, a video session recorded, and will pop up right here in this location, exact location. You can reach that location by clicking on the Technologies button and then scrolling a little bit. The very first item you see in the list is actually a module called Recordings from Sessions. That's where you will find Spring 2018. And below that, you will find Winter 2018. And like that, all the historical recordings are already available to you. So this is the session we did the last time in winter. Spring has already started. So we have a spring session going on. This session series has a bunch of videos, as you can see. And you should have access to it already. Please tell me, you don't have to watch these boring videos from old times like actually this year, January. You don't have to watch these videos. They're not required, because you're actually participating live. So you would be interested in the recent videos that we do actually with you. Those videos are interesting to you. Probably these ones are not. However, you have access. You can see them, see what we did in the past. And I might refer to some of these videos in the past if I cover some new ground. And if that happens, we will, hello, Gustavo. How do you say your name, Gustavo? Or Gus? Gustavo, how do you say that name, Gustavo? Hello, Gus? Yeah, you're muted. Let me unmute you. So hi, speak up. How are you doing?
Can you hear me
I
now?
hear you. Gus? No, I think we had an audio problem with Gus. But I hope if that problem persists, I would like to fix that. What I would like to do is, there is chat. So there's a chat message. And so the chat message is reading that chat right now. The chat message says, can you hear me? Oh yeah, we cannot hear you. That's a problem, Gus. So Gus, we need to fix that. Let's fix that. No. Let me ask you to unmute your mic. And yes, you can call by phone, correct, of course. But
can you hear me now?
Yes, I can hear you. Can you hear me now, Gus?
I can hear you.
How do you say your full name, Gus? Gustavo? What's the right way to say it?
Gustavo's good.
Gustavo is good.
Calls me Gus. Yeah,
whichever is easier. Good. Sorry.
Whichever is easier.
Oh, that works. I can say complex things. I hope you don't mind my butchering your name, but
no worries.
I hope not. So what I was talking about is to telling you that we are recording this video session, and at the end of the series, end of every session, we will have a video recording. That recording pops up right in this location. You can see my desktop, technologies, and then scroll. And then we have this location where we keep our recordings. The recordings are already available for winter 2018, the last series session we did. They are already here. You can watch them. You're probably likely to get bored. So we'll focus on spring. And that is the one where we don't have any videos yet, but we will create them. We are creating one right now. It is being recorded. I just want you to know that we are recording the session.
Okay.
So this recording will pop up like a red dot shows up in your screen somewhere. That's an indicator that it is being recorded. If you don't see that red dot, then I have a problem, because then I don't have a recording to give you, which is going to be bad. Occasionally I forget, and I'm very, very forgetful. So that's the reason why I want you to know that, hey, please remind me. If you don't see the dot, remind me to start recording.
Okay.
Having said, let us proceed with introductions. So we have, a small group. We have, I think, 6 people right now, and that includes me. We have one more joining in any moment. And let us begin with introductions. So my name is Nilesh. I am the founder of this company. This company is the company called Cloud Genius. It's a separate organization. It is not a part of Bellevue College. You will see Bellevue College right here. And this is the college location. If you go Google search on Bellevue College and actually search for cloud computing, you will find something which is kind of unique, in that what we have done is we have taken over the cloud computing curriculum for Bellevue College. My company has taken over that curriculum. So we run the entire program for them. So here is the tweet from Bellevue College that's saying, learn about our partnership with a top educator in the field, and blah, blah, blah. So you can read more about it. You can actually go click through that and read the blog post that they write about. And, here's my details about the program. And that is where I think most of you are participating through. Is that right? I think so. So what we have done is, if you go to, say, here, if you search for cloud computing in Bellevue College, the entire website and the page actually talks about Cloud Genius. The programs and the details and everything is actually links back to us, to our website, back here to this. No, not this. Come on, Twitter, go away. Here to this technology segment, the DevOps segment, and the architecture segment. That's where you should. The links will bring you back. The content is what I created. I created this entire structure, the entire setup. We now have this current site, which is line number 3 that I'm mentioning, which is currently you're looking at. You should have a login there. If you don't have a login, please tell me right now. I'll fix it. Also, please tell me if you have a login for another new site that I'm building, which is line number 4. In this location, you should be able to log into this location at that address, line number 4. Please tell me that you don't have a email address, login, password for that different site. If that's the case, I would like to fix it. Next one, I would like to make sure that we participate, we discuss, we interact through another website, which is another tool that I have put together. It is discuss.thecloudseminar.com. In that location, we will discuss. We'll participate, ask questions and things of that nature. So let's go see that line number 5 right now. We'll go there quickly. Open the browser and go. And we'll see that it has a discussion forum. You should be able to log in using the Cloud Seminar login that you have, and it'll take you straight to the location where I'm talking about. That's where the discussions happen. Anytime you need something or want a question, just click new topic and type the topic name and the detail. And I live here, by the way, in the forum. I live here, literally. And so what does that translate to? Is I answer immediately. I absolutely, the moment you type here a question, I will respond immediately. You see an answer. If for some reason you're not able to access this site, let me know. I will fix it. Let's keep going. We also have a Slack channel that I mentioned. You should have this line number 2 that I talk about. Slack chat works like this. In case of something emergency that you need immediate help, you are welcome to use Slack. That's where I welcome all of you. So I should be able to welcome all of you to the Cloud Bootcamp. Right there. I just welcomed you. Can you just say hi there or post a message somewhere in this discussion? They're all linked, by the way. All these sites are totally linked together, except number 3 is not. This is the current site that currently goes on, but all other things are currently linked with each other. That means Slack and the Cloud Seminar and the discussions and all of them are integrated with a common login. So I see somebody responded. Let's see what they're saying. Jessica says, I'm back. Hi. So that's nice to know. Nice to see you. And like that. So these are the tools that we'll be using. So like that understood. I also want to point out that the exact dates of the program. So for example, the dates and times are already listed right on the front page, right here. In this location, you will find the exact dates on which we will run the bootcamp in a video conference session just like this. We talk, we participate, we understand, we interact. And we are different in what you will see in the most programs is that we do not tie ourselves with one particular cloud service provider. Like, I used to work at Microsoft for more than a decade, but I am not focusing this program on Azure Cloud. I've kept it neutral. So the reason I was talking about neutrality is important is that it lets you pick and choose the right set of solutions. I also made sure that this entire bootcamp is focused on open source, meaning we'll use open source as we go along. So bottom line is I want you to remain aware of the fact that we are open to any idea that you have that you need to focus in your work. Whatever work you currently do, if you find something of interest that we should discuss, please bring it on. I will include it. That's how we run. That's how we have evolved the program over the years, is to focus on what your needs are. And there is no set requirement that is placed on top of me because I don't work for anybody. I'm an independent company. I drive my agenda. I drive my curriculum. It is my curriculum. Bellevue College does not dictate that. They do not. So I want you to know that I am very flexible in the curriculum that we have currently. You can add something to it if you like us to cover. If you can remove, if you want something that is boring and not interesting, you can ask me to remove it, skip it. I will do that. We have the content already, but I just want you to be aware of the fact that you can also drive the agenda and the content. So what I'm basically suggesting is that I think I need to put a do not disturb here because I'll strangely get lots of messages. So I'm setting do not disturb flag on multiple machines I have, which there we go. So that will take care of. So now point back to here is to focus on open source and vendor neutrality. Those are the key principles that we operate on. So we don't tie ourselves with one particular company or one particular vendor, but instead we focus on what is needed by, by the customer, by your employer, by your future customers, and look at what their needs are and try to solve their problems. That's the primary focus that we have. That's what we do. That is me. This is my picture. You can also see me physically and by the way, many of you are apparently in our area, in Seattle area this time. Sometimes people come from other places. This time, most of you are here. So I welcome meeting face-to-face in person. We can get together for coffee or something at some point in time. Having said, I was going through the motions of introductions. And what I would like to do is to request each and every one of us, one at a time, beginning with the alphabetical sequence of Ed. Why don't you please introduce yourself, Ed? Ed? Thank you.
Can you hear me now?
Yes.
Okay, 2 mute buttons. Yeah, my name is Ed, and I work for Boeing, and I just actually changed jobs within Boeing to a cloud computing group. So I thought this would be a good time for me to get up to speed on the technology, and live in Bellevue, and been with Boeing for 31 years, and have 2 kids, and I don't know. I think I think that's about it. What else would you like to know?
I think this is good start. So thank you very
Okay.
much, Ed. And just want to confirm that I have too many emails from you. Like I have, I want you to pick one. I think Butch 7575 is the one that I selected. Is that the right email?
Yeah.
I have variety.
I wound up having several Slack accounts. I didn't realize, so I
No worries.
deleted
You
them
can,
and redid it.
yeah. Don't worry about it. Don't try to, disable or deactivate account. I saw you deactivated 2 of them, which is fine, but doesn't matter.
Okay.
It's immaterial, so we can handle that. No problems. All the issues regarding logistics or anything, don't even bother about these things. They do not matter to me. Should not matter to you also. We'll just handle it. Just if you need something, just tell me. I will fix it. That's how it
Sounds
goes.
good.
Yeah. Let's go with the next person on the list here. Ed, thank you very much for the intro. The next person is Gustavo. Hi, Gus. Hey,
Can you
Gus.
hear me?
Yeah. Yes. Yeah. Go ahead.
Okay, so my name is Gustavo Luna, and I work for the Boeing Company. I've worked there for about 8 years now. I started as a developer, and I've changed roles from project manager to DBA to architect. And right now, I just joined an operational support system, part of the enterprise architecture team in the Boeing Company. And we're working on a new initiative to try to improve IT services. And one of it is we'll be working with different vendors, cloud vendors, including. So we will be working with Microsoft, Amazon, as well as Google. And one of the reasons that I'm interested in taking this course is because I would like to know more about what are the strengths of each cloud solution. Because we want to be able to build an infrastructure where we allow our developers to be able to pick and choose which cloud solution they want without being dependent on just one. So very excited to learn about more about the cloud solutions.
Yep, vendor neutrality, as I call it. It doesn't matter which vendor we pick and choose from, because what really matters is our customer. Meaning, in your case, the Boeing Company and Boeing's customers. That's what is, I think, the key. So thank you, Gustavo.
Sure.
Let's go to the next one. We have Jessica. Hi, Jessica.
Can you hear me?
Yes.
Yeah, Jessica Chen here. I also work for Boeing Enterprise Strategic Architecture Group, same project with Gus. I'm here to learn cloud as much as I can.
Nice. I guess some of you are team members. That's nice to know. I did not realize until later when somebody told me that I know a couple of other guys. That's
you have four in the same team here.
Wow. So we have a team meeting essentially. Is that right?
Yeah, pretty much.
I know. That's so awesome.
Yeah.
So, that actually makes it a good point that you should focus on your team's project work that you're doing, and let us do this project work in the most optimal fashion. Find best of breed solution sets and apply that to your work. I think we have an all Boeing team this time. We don't have any from any other company in this run around. We had in the past, we have other companies occasionally, but this time it's just Boeing apparently. That's what it looks like from a quick look. So that's going to be interesting. We can focus on talk just about Boeing. We don't have to worry about other things. So we'll do that. Unless somebody from another company just signs up at the very last minute in other sessions. So we'll find out that. But right now it looks like it's all Boeing. And we have total of 6 plus me. So that's a total people number 7. Awesome. Let's go to the next in the list. We have Kenny. Hi, Kenny.
Hello. So I'm Kenny Nguyen. I am also on the same team with everybody else in here pretty much. I joined Boeing we're coming up on 2 months, and I'm also new to the Seattle area too. So everything's all new to me. I have a background in mostly support and project management, system administration, that sort of thing. So I have a little bit of cloud experience, but not too much. But everybody seemed to agree that this would be a good course for us to take and help us with our initiative of modernizing everything. So,
yeah. Boeing is doing a great job in terms of, making sure that the people are upskilled, infrastructures are put in place, using open source, using a variety of cloud solutions, basically enabling agility from a digital enterprise at the top level. That's where it's coming from, I think. And so we understand that. We have been doing this with, almost roughly about 50% of people who attend the bootcamp are Boeing employees. Rest, we have Microsoft, Hitachi Data Systems, Expedia. Sometimes the US military does a specific program for them. So we have a variety of people in that participate, but half of it is Boeing company. I guess it is, the program seems to be aligned with your needs. That's what it sounds like.
Mm-hmm.
Thank you. So let's thank you, Kenny. Thank you very much. And let's go next. We have in the list, we have Tina Tran. Hi, Tina.
Hello. Wait, am I muted myself?
No, you're not muted.
Oh,
you're
okay.
You're audible. Okay, I can hear you.
Okay. So similar like Jessica, I guess, and Kenny, in the same team as they are. So I've been with the company over 20 years, and but mostly it kind of has been like a business and IT, but supporting mainly the process and application development in several mainly multi-dimensional reporting systems. And this is going to enterprise architecture team is quite new to me. And so it's like everybody else and trying to speed up with some new technology here again and get familiarized with cloud so we can support the team better.
Sweet deal. Thank you. And as I said, our focus in this group is a small focus group. We have 6 people, all of them Boeing, which means we can just talk freely about whatever you have in mind. There is no need to worry about other companies getting to find out about information about what you are doing with. So but by the way, that having said, I would like you to be aware of one thing very, very clear, that I am not a Boeing employee. Just want you to know that. So don't tell me anything that is company secret. Do not discuss that. Just want you to know, accidentally you might. That is company secret. Please do not discuss that. I am not a Boeing employee. Do not again repeat, please do not discuss that with me. Thank you. Remember that, by the way. And so if it is secret information, just tell me that. I will not be able to tell you that, and that's fine. No worries. I understand that. It is it's a big company. You have certain policies, you have certain requirements, you need to follow that. And one of them is to make sure that you don't disclose company secrets. So please don't. That's it. Okay, let's keep going. So we discussed brief introductions. I think I gave you my intro. If you haven't read or heard more about me, you will find out eventually. But a quick way to find more about me is just go to LinkedIn, and here you will find me and just connect with me, and we can always talk about it. So you can go to the profile location here, and that's where you will find my profile. I will also put that in this notepad, which is somewhere here. Excuse me. That's where you can find me, and you're welcome to link with me, and we can of course interact on a social level outside the bootcamp. Let's see. There is a chat message. The chat messages are. So I see only Jessica's chat. So this chat is important in Slack. There is also multiple ways to chat, and I want you to know that I do not use this chat that is a part of Zoom software. There is a chat method in Zoom. Let me just chat there to tell you that I don't use this. That chat I do not use. The simple reason is that chat doesn't persist. If I break the meeting, this chat will go away, and that's not what I want. I want the chat to persist at least through the duration of the bootcamp. And so therefore I use Slack, which is this. And I want you to be able to chat with me right here if needed. So if you need something, just quickly type here. That's the way to chat. This is a spring 2018 group. In that group, we have members. And if I see who the members are, it is just all of us. You can see that view members. Where are the members? View channel details. And so here, Ed, Gus, Jessica, Kenny, again, another Ed, and these guys might show up later on. Tina, and one more person who is not in this Slack chat quite yet. So this chat is what I usually use for anything that is we need to quickly exchange some idea. That's where you come and chat. You're going to ask a question, you go to this discussion that we have line number 5. That's where we go typically in that location, which is this location where you can ask a question. If you have to type some detail and describe it, it's a fairly easy way to describe that question, and I will immediately respond. My response times are typically in minutes as opposed to hours and days. I usually do that because I love doing this. This is not just my business. It is also my passion. I created this thing that you look at. Where is that? This Cloud Genius thing I created because I wanted to. And so I built this company. In this company, if you did not know this by now, it is created in 2009 when we started building. And over time, we have created a new bootcamp program that started about 5 years ago. And I have been recording every single session like this since 2016 timeframe. So we have years and years of experience of delivering training online just like this. And we have evolved the program quite a bit. We have thoroughly revamped the program because people like you who participate will give me ideas on what you need. And I will just gladly accept that right into the program. That's how we have evolved it. And it seems to align with exactly what you need. If you don't want something, I'll just remove it. And I can do that primarily because there is nobody who's my boss. There is no control agency that controls me. But apparently because of this thing that has happened is lots of people that have participated in the past, you can see them, they have given us beautiful testimony of what they did with the bootcamp. And as a consequence, what has happened is this magazine called CIO Magazine, they have rated us as one of the most valuable certifications today. The site is opening up. It is kind of hard to believe for me, but this happened. The most valuable cloud computing certifications today. In that list, from this magazine called CIO Magazine, you will find there are companies like Red Hat and AWS and IBM and Google and Salesforce and VMware and there is Cloud Genius. This is mind-boggling even to me. I did not believe this when I saw this first time. It is only late last year it happened. This is mind-blowing. It happened. I found out how and why it happened is because of people like you who participated and actually gave feedback, like this guy says. There are a bunch of people who have done the program that have talked about, and the magazine interviewed them, and that's when they decided that this actually is a good place to learn. That's the thing that we have found out. I did not know when it published. The way I found out about this article in the magazine in the top certification programs was through a tool called Google Analytics. You may know this already. This tool called Google Analytics is how people who run websites and web services are able to identify where the traffic is coming from. So I was analyzing the traffic data on Cloud Genius website, and I suddenly find a large number of links coming to the website, but originating from the CIO magazine. And I said, what is going on there? And that's how I found out. Having said, let us now actually start discussing the meat of the stuff, the actual stuff. Now, in here in the program, there is this site that I would like you to take a look at, which you have, I think, let me paste these links to you. A bunch of links. So one of them is, let me just paste the links. I'll remove these numbers. That's one. Here is another. And they're all linked with each other. So don't worry about it. But you need a login on the very last link that I will give you. And that you have a login already. If you don't have it, please tell me that you don't. So here are the links that I would like you to be aware of. And these 4 sites, I'm going to paste that in Slack chat right now, right here, like there. So these links and these sites, said somebody in general channel. And so, oh, there we go. Aha, I see. See that linkage happened in this general channel post came along through a post that Jessica just made. And so I love that. Thank you. And this just started. Jessica just made a post in there. That is beautiful. That's exactly how I expect to perform. And all these sites and services I have already linked up and connected. And I'll walk you through what I did as we go along. But again, that's not the beginning point. The beginning point I want you to make sure is that you can access these sites correctly. And so I haven't heard from anybody that you cannot, which is an assumption I'm going to make. Is that
no, wait, I'm Sloan here. I got into the access discuss, but I can't get to what that chat page right there.
Which location, please? Can you share your desktop?
Share my desktop. I'm having 2 screens. I'm kind of
at the bottom, there's a green button. And so please share your desktop. I want to fix it right away. There's a green color button at the bottom. So share your desktop and I want to see what's going on. So now I can see your screen, Tina.
You see my screen?
Yeah, I see your screen. Now you see the access.
This is where I got to.
Great. So you want to create a new topic. You click the new topic button. You see that button is right there. The new topic button is right there. That's how you create a new topic.
No.
The new, you click on the new, and on the upper right corner, there is a new topic button. There we go. That's a new topic button. You just ask a question right here.
Tina,
right?
Are you talking about Slack chat? Is that what you're having problems with?
No,
the discuss site.
Cloud Seminar.
Right, the Cloud Seminar discuss site.
Okay.
Yeah.
So that is where you can just create a new topic and post, right?
Right here? Okay.
Yeah. Anytime you have a question, just shoot right there. And I will immediately answer that. Now, the other access that you want to have is this location called access, that you should already have access to that because you're logged in here. So it's already connected. So I guess you have access to that. Now let us go back to my screen. I'll now share back my desktop. So I am asking you to please stop sharing and I will share my screen right there. And in here, you will find that there are some material that I would like you to access in technologies, in DevOps, in architecture. There is a whole host of content available. We have this as reference material. You don't have to review each of these videos, but it will be a good idea to review the other things later on. And I will be opening up access to all of these DevOps and architecture. Also, right now, you have access to only cloud technologies. So let us focus on the cloud technologies piece. And here, there are lots and lots of things to do already. In addition to the recordings, there is some brief introduction about what these things are. And this is the material. There is a little short video. I'm not going to play that video. This is like a 46-second long video. I'll shut it off right now. I want you to read this on your own because that's the reference material that I'm pointing you at, is that I would like you to read this at your own whenever you find time so you can get more additional content in addition to what I provide interactively face-to-face. Now, we will begin the actual content. And as you will notice that I don't use PowerPoint. What do I use? I use a whiteboard that looks like this. It's basically plain white sheet. And I'm erasing this. And I'll beginning with one topic. The topic is called cloud computing, right? And so we will begin understanding what is cloud computing, right? So we have to define it. So definition. Who defines it? Is it going to be me? Is it Amazon? Is it Microsoft? Who defines it? Do you know? Google, maybe? So no, they don't define it. We don't get to define it. There is a standards body. Do you know which body I'm talking about? There is a standards body that defines this thing. Do you know who that body is? The United States standards. What is it called? Let's go Google. If you don't know the answer, don't worry. Nobody knows everything. Even I don't know every single thing, right? So there's no issues. We have what we know as Google. So let's go find out what is the standards body. It is called NIST. The website is nist.gov. That is the National Institute of Standards and Technologies. This body is an agency of the US government, which has the role to define stuff for us, like stuff as in anything. So they define standards. When they set standards about what is this, what is that, what does it mean? They go to basic stuff, like they define what is the length, unit of time, unit of weight. So basically all the things that are necessary in terms of physics, chemistry, math, and standards and operations and this and that. So it's a large operation. But they happen to have defined cloud computing also. So let's go read their definition. Right there. And so here's the definition. And it's a highly boring read. It's right there. You can read it all day. The publication is actually right in that link. And if you look at the PDF file, it's opening up right now. And it is, where is the PDF? No, that's not the PDF. So here, maybe at the bottom, the definition of cloud computing is that PDF available at, come on. They'll break the links all the time. Why? I cannot find cloud computing definition. There it is. So that's the PDF file. So this is the definition, abstract keywords, and let's go that publication document itself. And this is the documentation that defines cloud computing. I will paste a link for you in Slack chat, so you have access to it readily. So the Slack chat, and here's the link. Now here is a good bedtime reading. I don't want you to fall asleep because I'm not going to read the whole thing, but I will read parts of it. The reading is quite lengthy and it's quite, in my taste, boring because that's not how you write stuff. But apparently that's what people do in standards organization, is they make things boring. And I don't want to make it boring. So I'll make it interesting, at least to the extent possible, technically possible. By the way, at that point, I would like to tell you something which is important, is anytime you find that I am boring, you should stop me. Literally, hey, say, Nilesh, stop it. You are boring us. That's how exactly I want to hear from you. And you will be, by the way, doing me a favor by stopping me. So I hope you understand what I'm saying. And I want you to actually say this, that Nilesh, please stop. This is boring. We are falling asleep. Literally say that. And that's okay with me. As you will notice, I'm not a college professor. So I'm more like you, that like I used to be a Microsoft employee about 7 years ago. And so this is just like you. I'm a person like you who is, more like a person that works in a company than a professor who teaches at the college. So I'm not a college professor. I don't take offense. It's totally fine to just tell me, hey, Nilesh, you stop. You are boring. So please do that. And I will encourage you to do that because it is in my interest to keep you excited, because that's what you will, keep your attention. Attention is the most expensive currency today. I want you to keep your attention on what we are discussing, because the moment I lose you, we have a big problem. And I don't want you to lose you. So I want you to be excited about what we are doing. And if it is not exciting, that is actually my problem. I am making it boring. So you're falling asleep. That's my problem. So help me fix my problem is what I ask. And I want to thank you for that. And yes, I will actually thank you. So anytime it gets boring, just stop me, say, hey, move faster, move slower. Both directions are okay. Sometimes I speed up way too much. I know this because there is so much of content to cover. And sometimes it is not possible for you to keep pace of what I'm going through. So it is okay for you to ask me, hey, Nilesh, slow down. Or in other words, the contrary is also okay. Hey, Nilesh, please speed up. You're too slow for me. That's also okay. Too slow, too fast. I can adjust my pace. And also I have this Indian accent. So if you cannot understand it, you need to tell me that I cannot understand your accent. You need to tell me that you're too slow, too fast, too boring, or anything like that. Please don't hesitate. If you feel like you should speak on a private session, That's also okay. You can do a private Slack chat and tell me that, hey, Nilesh, you suck. That's fine. Totally fine. No problem there. But please tell me that. That's what I want to hear. So with that, let's go read this boring definition. It's actually not boring, but they just write it very, very boring in a boring fashion. But that's the standards organization. So we have no other way but to read the standard. That's the only way, I think, is the only authoritative definition of cloud computing to me is this. So I will just use it instead of me coming up with my own definition. So let's go read only parts of it, not the whole. So here, the beginning is right here. Let's go focus only on the first sentence, which is the first 3 lines right there. That's the portion I want to focus on, and let's go read that. Only parts of it. Let's begin with the top. Cloud computing is something, it's a model. Model for doing what? Enabling something. Okay, enabling what? Ubiquitous, meaning any location, doesn't matter which. You can be in Zimbabwe or Canada or India or China or wherever they are, wherever you are, the cloud computing service is available to you. That's ubiquitous. It is convenient, meaning you don't have to go anywhere. It's just right there in your face, like open a browser, deal with it. Open a command line like this and handle it like that. That's how you expect things to work, right? I'm opening my command line, something is apparently not working, but we can ignore that and we can move on. That's the expectation, right? My command line is available to you, or rather to you on your machine, and I have on this machine, and I have a browser. I can just operate on anything I feel like. So those tools are available to us at our fingertips. It is really, really convenient. You don't have to drive anywhere. Like even to attend the cloud bootcamp, you don't have to go anywhere. You just sit right where you are. Maybe you're driving. Some of us actually, honestly, don't do that. But I noticed that at 4 o'clock, apparently some of you are driving at that time, which is fine with me. Just please pay attention to the road, not to the boot camp, and always catch up later on because we have a recording. So no worries there. But when you're driving, please focus on driving. Get to a point where you can just stop and then participate. Please don't type or chat, Slack chat with me while you are driving. Thank you. Thank you. Don't do that. Some of you have done in the past, and that is bad. Bad for you, honestly, but just saying. So don't do that. It is very convenient, like conveniently run, attend the boot camp and participate, and all that is fancy stuff. Yes, we are living in that world, which is things are easy and fancy and convenient. And it is on demand. On demand. This is not what Cloud Bootcamp is. Cloud Bootcamp is not on demand. It's a deviation from the definition because that's what it's a bootcamp. It's not a cloud computing service. So this definition is actually about cloud computing services. They are a model for enabling certain things that are ubiquitous, convenient, on-demand access. Network-based access, meaning you have to have internet of some sorts, either in the private area, like a private network within the company, or online on a telecom provider or a Comcast like cable carrier or some other way of connecting to the common internet. That network is necessary. If you happen to be in India where you don't have internet, too bad, you cannot access. That's the understanding. That's the situation. It is on demand. As long as you have network and access to that network, you can then use the services provided by cloud computing. So it is essentially about enabling anywhere access, convenient on-demand network access to something. So these are the characteristics we're talking about here. Ubiquitous, convenient, on-demand network access. Got it. Got the characteristic part. But access to what? Access to something like a shared of what? Shared pool of configurable computing resources. So configurable computing resources essentially means, three things. If you look at the resources in broad computer science, there are three types of resources. They are the compute resource, the storage resource, and the network resource. These are the three broad classifications. If you look at my computer right here, I see that I have a CPU right there. And then I have some storage right there. And then I have some network right there. And in that network, I have a Wi-Fi connection and an Ethernet connection and a bunch of other things. So that's my network capabilities. And that's what you saw just visually from my computer perspective. You have some storage, some CPU, so the compute horsepower, some storage, and some network capabilities. These are the resources that I'm talking about. There are three different types, three types. That's what essentially we are talking about here. It's a shared pool of configurable compute resources. What are compute resources? Three things: networks, the networking part; storage, the storage part; and compute, where the applications actually run. That will involve applications, services, and the servers that will put these things together. Essentially, this thing, compute, storage, network, where compute you will have an application that will run on the CPU itself, that will use the storage and also use the network, will generate an application, and you can then use this application as a service. You can run this as a service. So that's the idea from a top level perspective. Let's go further in terms of identifying this word here, shared pool. What does the shared pool mean? It means that these resources that we have, the three things that I talked about, storage and compute and network, these things are shared. Shared among what? Who? Who shares it? Shared among people. Right? Literally, that's what it means. It means that you have, in a very simple example, you have this machine which has how much memory? 16 gigabytes, right? See that? Now I want to share this total available memory with another machine. So I start my other machine that looks like this. And in there, I have a settings button to look at. And I find that in the other machine, which is in that machine, I have a system setting which specifies that it has been given a base memory of 2048 MB RAM. Okay. So if I now start this machine, this, by the way, you're looking at is a virtual machine that some of you already know. Most of you already know this, what a VM is. But this VM is basically, if you don't know VM, please tell me. One-on-one private chat, welcome. If you need to brush up on things like this, we'll do a one-on-one session as needed. Don't worry about that. So I'll certainly make certain assumptions that you already know what a terminal is and what a command line is and what a VM is. If those things are not true, if the assumptions are not true, that's okay. You can just do a one-on-one session with me and I'll catch you up. No problem there. Just tell me on Slack chat in a private one-on-one chat that you need some help. And like a private chat will be not in this group, but you have to go look at my name. So you have to find me. And so you just click on my name and then send a message Nilesh button. So you say hello, like that. You can send me a private message or just call me. You have my phone number. We'll do a one-on-one with you to catch you up if needed on a particular topic of your interest that you may not be aware of. So we'll do that. But this is a VM. If you look at this machine itself, it has its own start button. I mean, not a start button, but this is Linux desktop. And it's on about the computer. And here you will find it has memory of 2.0 gigabytes. Whereas the actual machine had how much memory? 16 gigabytes. So something is happening here. Let's go find out what's happening. We'll go back to our whiteboard. And we had a total of 16 GB of memory in the machine itself. This is like a physical machine. And what I have done is I have divided that into smaller pieces like that. So this is 8, this is 8, 4, this is 2, and this is 2. That's how I have divided the total of 16 GB memory. And I decide to allocate this memory to that Ubuntu machine that I have. So I'm sharing my resource of 16 GB with the Ubuntu machine. And the rest here all this area, all this memory is still used by the Macintosh. That's the concept of sharing we are talking about here. Shared pool of resources. You have some resources under the hood here, storage resource. Out of that, we'll have memory resource and disk resource. So we look at the disk here in this machine and the virtual machine that we are looking at. If you look at its disk capabilities and find out how much disk does the VM have, we'll open up and say disk, how much disk you have, and you can find out the disk available is roughly about 110 gigabytes. That's the disk capacity allocated to this machine, which is a Linux machine, 110 GB. Now the actual machine here has a storage capability of 1 terabyte, out of which 592 is taken by something like occupied, and rest of it is available. 592 is available, fine. Rest is taken. So out of the total disk available, we are sharing some disk. Out of the total 1 terabyte that we have, we are sharing about 110 GB of the disk and giving it to Ubuntu. The rest of the disk is available for use by the Macintosh. That's the idea of under the hood of sharing. Let's also see two more things in sharing. So this idea of compute. On the machine side, we have the machine itself showing us that there is a CPU which is 2.8 gigahertz of Intel Core i7. That's the machine, right? That's the CPU here. That is nice to know. Let's keep it aside here and let's ask this guy, what is the CPU you have? And here you will find this has an Intel Core i7, basically the same CPU, but how many cores are allocated to it? In totality, I think my actual machine has about 8 cores, or maybe 4. I don't know. I'll find out. Let's go see. We'll go to Activity Monitor, and here we will find out how much CPU you have. And currently, you can see that the Zoom process is taking up about 125% of CPU. And if you look at the total available, I think there's a better way to show this. Let's see if I have the other way to show this. On the command line, and here you can see we will have a total number of cores showing up somewhere. It's not showing you. But essentially, I'll find out a way to show you this idea, what I'm talking about. Essentially, what's going on is in the total number of cores that we have in the computer, in the actual Macintosh computer, out of that, I have allocated 1 core to the Ubuntu machine right there. And I think you can see that in the virtual machine definition itself. If you go to the VirtualBox machine definition and look at its settings, in the system area, you will find the processor allocation is out of 8 CPU cores available. I am allocating only 1 to the Ubuntu machine. So practically, it is a 1 out of 8 sharing scenario. I am sharing out of 8 cores available to me in the Macintosh. I have allocated 1 core to the Ubuntu machine. Ubuntu, write properly, Nilesh. There we go. Ubuntu machine gets 1 core out of total of 8 cores. That means total remaining cores available with Mac is only 7. That's the capacity for work that this Macintosh can handle, up to 7 cores, because this is dedicated to this Ubuntu machine. So that's the sharing in the CPU aspect of it. In the network capabilities, the last idea about sharing that I'll talk about is if you look at the entire network collection that we have in this machine, in the Ubuntu machine, let's look at its network characteristics. And you will find that I have a Ethernet adapter with this address, and that adapter is actually connected not with a physical cable, but through a software router, which is sharing my actual Ethernet cable. So my actual Ethernet cable will show you a bunch of different adapters. This is a very, very large configured machine, and you will find a bunch of different adapters popping up in this list. And I'll focus on the only ones that are important right now. So the one that is actually being used is this adapter, EN0, which has this IP address. And that's the address for the actual machine Ethernet adapter. There are a bunch of other adapters. We'll discuss these things later on, but I want you to focus on the idea that out of this adapter available, out of the network capabilities provided to this Macintosh at this IP address from that adapter, what we are doing is sharing it with the with the Ubuntu Ethernet 0 ETH0 adapter, and that essentially is getting a different IP address as a virtual IP provided to the VM from a router inside VirtualBox software. That is how we are enabling network sharing. So we are essentially sharing stuff. Go back to the definition now. Here, read. So it is shared pool of computing resources that involve network, storage, servers, blah, 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 all these things. Basically, three things. They're not these many, but in practice, that turns out to be compute, storage, and network. That's what you can translate that back to. Everything goes back to these three things. Three things put together will constitute some kind of a some kind of a compute architecture. That's what we are really talking about, configurable computing resources. You want to share them with other things, and then you want to share those things with other people at some point. Now let's go read further. Like here, that can be rapidly provisioned. Rapidly, that's the keyword, is quickly, and released with minimal management effort. Minimal management effort. Or service provider interaction. That's a key thing to remember. Here, minimal management effort and without service provider interaction. You do not call somebody, hey, can I please get a machine like this Ubuntu Linux for me in 2 minutes right now? You don't have to make a phone call, but you can get access to such a machine in a matter of minutes. Have you done such a thing? Please tell me that you have. So at least I'll get a level set as to where I'm dealing with. What I'm trying to do right now is to get some level set going with you to understand your current set of capabilities of exposure to using cloud services already. Some of you may have, others may not have, but that's okay. I'm just getting some understanding of what level of familiarity do you already have, because I will cater the program to your needs. I need to know if you have actually done these things already in the past. And I'll give you an example of what I'm talking about. What I'm talking about is, have you ever asked a service provider to give you a machine and you received it in like a 2-minute window and you accessed it and you made your work, whatever you were working on, you did that work and you were happy about it, and then you released it? Have you done such a thing in a matter of few minutes? Anybody?
Not in a few minutes.
Okay.
Takes a little bit longer.
Yeah. How many minutes? Are we talking minutes or hours or what?
So it depended on the server. So like a Linux box, for example, would seem to be a little bit easier to spin up. It only took them an hour or so to go through the.
Mm-hmm.
I think it was mostly policy stuff that got in the way, because obviously it's quite easy to spin these up.
I know. That policy is the killer here.
Mm-hmm.
So what happens is that, if you read the definition again, we have to be rapidly provisioned, right? In matter of minutes, literally, and released with minimal management effort. That's the demonstration I would like to give you now. Like, actually, I'm doing this for real. What I will do now is go to a cloud service provider and ask them, can you give me a machine? I will not make a phone call, by the way. No phone calls. So minimal service provider interaction. I will not interact with them on a phone. I will just go to their website like this, for example. I'm going to some company, this cloud company that I seem to like. I just log in and I say, hey, here is my password. So please take the password and log in. And then, come on, log in like that. Yes, proceed, please. And then I will post my verification code and then I log in. So let's go on. Now that I'm logged in, I will now start the timer. Like I'm saying 2 minutes, I should get access to the machine there, right? So that's what I want to make sure that it actually a successful demonstration. I want to make sure that it actually works out like that, for which I'm making sure that my key pair is already matched up. We'll talk about these things later on, but before I start my timer, and I'll measure myself as to whether this service provider actually succeeded in making sure that they give me what I have in mind, like a machine in a 2 minute period. And that's what I am going to grab that key from my machine and give it to the service provider. Here is my key. Please take. And add the key there. Come on, add it. Already in use. That's good. So I was just double checking whether my key is already there with them. Looks like they have it. They have my key already. It is called Nilesh. That's awesome. So that's the key I will be using to connect to the machine. Now I will go to the front end of the website and say, can you please create a machine for me? And I will select and describe what types of machine I want. I'll say, give me an Ubuntu machine and I'll spend about $10 per month on this machine. And so go ahead and give that machine to me in San Francisco. And by the way, use my key called Nilesh and just create. So let's start the time, 5:03 right now, right there, clock. And the machine is getting created right now. As you can see, the machine is getting started. You can clock it right now. It is 5:03. And in a moment or so, you should see that the machine is ready now. And here it says that the machine is ready. And so I should be able to just go to this location of that machine and identify its IP address and then connect to it. That's the expectation, right? Just about a minute. It took about a minute. And now I should be able to get to this machine's IP address. I get my IP, the droplet has been created. So I grab this IP address right there. And then I go back to my command line and I say, hey, can I please connect to the machine? And it says, are you sure? And I go ahead and I connected. There we go. So how much time? 5:04, about a minute. It worked. That's the idea. So I don't want this machine anymore. So I say, okay, can you please get rid of this machine? I don't want it anymore. I'm done with you. So I'll say, go back to the dashboard and say, this machine, you please destroy yourself and go die. And that's what's going to happen. Destroy and confirm. And the machine is dead. Boom, gone.
Nilesh?
Yes.
I have a question.
Yes.
So, I mean, when you request, for example, that 2 GB memory at the beginning, but later on you want more memory, did you upgrade or you have to request a different machine?
Okay, good question. I will answer that. So, you can add more RAM. You can add more disk. But the problem with disk is that if you have stuff in the disk, let's say this bigger disk you have, right? And so you fill it up this way. And then you're running short on the disk space. And so you add more disk. And you fill it up. Now you cannot shrink the disk. Not possible. That's the problem. That's I think a reasonable thing to understand is that, if my disk consumption is more than the disk size that I now want, you have to first reduce the consumption. Only then you can shrink the disk, right? That's reasonable. You with me? The disk is kind of full. You cannot shrink the disk. So the shrinking is not possible. Adding is okay. Shrink the disk is not really a good idea. Doesn't work. because you're occupied. So you cannot shrink. So that's the idea. Yes, you can add RAM. Yes, you can add disk. You can add CPU. All of those things are possible. You can very simply create a new machine and add more RAM to it. All of that are programmatically done. You can do this through the browser, the web browser. You can do this through API call. You can do this through command line. All of these things are possible. Let's go back to the definition. Here, it says that we can rapidly provision and release resources, compute resources that are shared with other people. These resources are shared with other people, right? There may be other people like me who are on the cloud and want to get access to a resource. They also can get access to a shared pool of compute resources on demand, convenient, ubiquitous, no matter whether I'm in India or here or some other country, but it will work. That's the idea, right? It is all these characteristics apply. I'm getting resources on demand, and I'm not even worrying about interacting with the service provider. It's very, very minimal, meaning I click some mouse, or I run some code, or maybe type some keystrokes. So these are the interactions that I'm doing. I'm not making a phone call, not making a ticket, not making a case, not waiting for anybody to give me a policy permission, all of that stuff. I'm just doing these things. That's minimal interaction. So that's the idea behind cloud computing right there. Actually, not there. It is these things. That's the first sentence we just finished discussing. Now, having said, let's recap on the sentence. It is basically a way to share hardware resources, software resources, network storage, compute resources with multiple people, multiple customers. In practice, if you look at, let's go to Google and find out some images of image search. Image search of images of what? You want to search images of data center. Look at a classic data center. That's what it looks like, right? So look at this data center, for example. What do you see? You have one in Boeing company, or many in Boeing company. You will have such a thing in your company. These boxes that you look at here, these big, large boxes, they will carry stuff. You know what that stuff is inside? It is compute. It is storage. It is network. What else do you have that doesn't fit into this umbrella? Probably not. Maybe there is something that you have exotic that I don't know of. But these are the broad compute resources. That's what you're looking at in this picture. So now we want to slice and dice and divide and, basically partition these things available to us. Like I showed you this picture of 16 GB of RAM, and I divide it, and I divide it further, and divide it further to make it 2 GB block. And I give this to the Ubuntu machine that I showed you. So now if I want another machine and I want a 4 GB size, I need to use this block. I cannot use this one, too small. Maybe I can use these two, and there are 4 and 4. So I can use 3 machines, 1, 2, and 3. I can create 3 machines with 4 GB each. But then I also need to feed my Mac. And so that will be, this space will be given to the Mac, right? So we have to understand and identify and allocate the available resource, the RAM resource in this example, or the storage resource, or the compute resource. I have 8-core CPU. I can divide that into 8 cores. So I can maybe allocate 1 core to the Ubuntu machine and another core to another machine, and I can run like 3 or 4 different virtual machines on the same machine, and then leave some cores for us to consume for the Macintosh. That is what is going on in these big boxes, so that we are partitioning them into smaller chunks and then letting other people access. That basically translates to this idea, is that if you have, let's say, Jessica occupying this portion of the machine, this piece, this slice, and right here, right next door, is somebody from let's be somewhat dramatic. The Airbus company. Imagine that, Jessica from Boeing company is here. And right next door to you is another company sharing resource. The Airbus company from France. They are your competitors, and I know and understand. You already know that. So that's the kind of a challenge that you are up against. That might happen. You cannot say no to Airbus and asking Airbus to get a machine right next door. I mean, next door as in like right, maybe sometimes it is on the same box. That may happen. Now, what do you do in that case? That is what we will also discuss. Those things, by the way, are plausible. It might happen that Airbus gets a machine right here, and Jessica has a machine right there. It could happen because that's how the nature of the beast is. Just want you to understand that. I don't want to scare you with that idea, but that's what we are reading now. Is that it is a shared pool of resources, meaning you can have your competitors right next to you. That means you have to provide complete bulletproof isolation. Even though you have your competition right next to you, you don't have to worry about these things. That isolation is provided to you by the cloud service providers. And they will give you guarantees about those isolations as we go along, as you use them. So don't worry about these things, but just want you to be fully aware of that is what shared resource means. That your competitor might be right next to you. Having said, we will now go to the second sentence. And I'll not make you read through the whole book or this is good like a bedtime reading for later on. But right now, let us focus on the 5 essential characteristics. And then there are 3 service models and 4 deployment models. So we'll understand that detail also and go in that direction. So let's go now. Before we change this, we are switching to the 5 essential characteristics, the discussion on that. And I want to ask you if there's any question up until now. Please, don't hesitate in just stopping me anytime. As you might know this, and you will find out, I don't keep any set agenda with me. It is purely driven by your needs. So I can adjust my content, my pace, and my level of engagement with you according to what you need, as opposed to thrusting my ideas on you. That is not my idea. I don't want to force you to do certain things that are not relevant. I will not giving you any assignments to do. I will not be giving you any test, or there is no exam. I just want you to be aware of this thing, because I am not dealing with high school kids. You are industry professionals. I don't need to test you. So there is no exam. Just want you to be super clear about that. Doesn't mean that I don't want you to work. I actually want you to focus on your current projects and identify how can you make use of the technologies and the things that we are taking in the boot camp. How do you take that and apply that to your work? I think that is where the most interesting things happen when you take the learning from the boot camp and apply this to something that you're doing already, and maybe you do it better than what you did before. I think that's what I try to accomplish, not in giving you a silly test, not in making you remember or memorize this and that and having to, no, I don't do that. Don't even make me think like that, because I don't operate like that. No, don't do that. I will not. If I do that, please stop me. Having said, you pause me, stop me anytime you get a question. Just open your mic and ask the question. Don't have to hesitate about, hey, my flow is broken. Doesn't matter. To me, it doesn't matter. You can always stop me, interrupt me. Is totally okay and welcome and encouraged. I actually encourage you to ask questions.
Nilesh, one quick question. Throughout the 3-hour session, do you take any quick breaks, or is it assumed that we just take breaks at a...
Very good point. So a point I would like to remind you is that I am highly forgetful, which means I forget to take breaks, which means you need to remind me to take a break. And I will, as soon as you mention the word break, I will take a break like you just did. So I'll take a short break. That's how it goes, because I completely forget, right? So I have a break method. The break, I run a timer here, so I don't overrun the break. So what I'll do is break timer 7 minutes. And I'll start the timer right now, and here our break starts. That's how we take a break.
Okay.
Okay.
So you break every hour or?
No, whenever you need. Typically like
Okay.
once in a session, maybe twice, but I don't need a break. You might need a break. So if you need a break, you just tell me. I'll take it.
Okay, thank you.
You just speak the word break and I'll break it right there. I don't need a break, by the way. Sometimes I do. In that case, I'll say the word break, but it's spontaneous. When you feel like you need a break, just break it. That's how it goes. Now that I have a break, I'll order some dinner for me. Thank you. Sorry about the delay. I think I overran the break, apparently. I didn't realize it takes more than 7 minutes to place a order to deliver it at my home, which is kind of crazy. Never ordered it before in a break. Maybe I will adjust my break timer to more than 7 minutes, maybe 8 or 9 or something like that. But it took me some time to actually place an order. So somebody will get me the food at 107 minutes from now, whatever that means. That's what this Uber Eats, DoorDash delivery services, that's what I'm using right now. Okay, so let's get back to business. I hope you are with me. Hope you can hear me properly. I am not muted and you are able to see my desktop. So we're talking about this data sharing, machine sharing thing, right? Back to our picture is the, we're actually talking definitions. So back here, the definition is right there. And we are going to begin discussing on this idea about 5 essential characteristics. And then we'll jump to 3 service models and 4 deployment models. That's the flow that we will take, by the way. By the way, this definition is actually how the entire cloud technologies segment will basically go through depths and depths and depths of each and every aspect of the definition itself. That's how the program is kind of sort of structured. So we talk about these 3 things, right? Which is storage, network, and compute. We'll go deeper into the great levels of depth until you get tired of me. We'll keep going deeper. If you at some point, if you feel that this is too much detail, please tell me that don't go that deep, come back up. That's okay. If you find that it's not too deep enough, you need to also tell me that it's not deep enough. That's how I can adjust my depth and my exposure coverage. But essentially, we are focusing primarily on what is cloud computing, understand the characteristics, understand the service models, understand the service providers, understand the deployment models. So we'll cover the ideas of the 3 service models also, which means infrastructure as a service, platform as a service, and software as a service, those 3 service models. We'll also cover 4 deployment models, which is public cloud, private cloud, community cloud, hybrid cloud. What does that mean? And in your company, in Boeing, you have a private cloud. You also use public clouds. So we'll understand that, and we'll discuss that detail. And we'll begin first with the 5 essential characteristics. And these are the necessary things required for something to be labeled as a cloud service. If you don't meet these 5 characteristics as according to the definition, then you're not a cloud, as simply as that. So that's how we will, it's our measuring stick. We'll use these 5 characteristics to measure whether something is cloud service or not a cloud service. For example, this cloud bootcamp that I run for you, does it meet the definition? No, it doesn't, because it is not on demand. So it violates that definition. So you cannot really call the cloud bootcamp as a on-demand access to education and training, because it is not on demand. It doesn't run on whenever you feel like. It is not like YouTube, right? It is running on Monday, Wednesday, Friday at 4 o'clock at Pacific time. I think most of you are here in Seattle area, right? I did not hear anybody saying I'm from away. So yeah, so Pacific time, I don't need to repeat that. But sometimes other people join from other places. So it is not on demand. So that's a violation of definition. So therefore, I cannot call Cloud Bootcamp as a cloud service because it broke the definition. Okay, let's go see the 5 characteristics. What are those? They are defined right there. And here are those. Essential characteristics. They are essential. So first one, on demand. What does that on demand mean? It means I go here whenever I feel like, on demand, click a button, click the machine size, and choose my location. I want it in New York. No, I want it in India. Fine. Select that and select my key and boom, create. Click the green button. That's the idea behind on demand, whenever I feel like. By the way, almost every cloud service provider is structured just like that.
Nilesh?
Yes.
Quick question on the So with the cloud, when you said can be in anywhere, so can you quickly was it because of that service provider? Why is it important we need to select which the location of the data center to use?
So the on the ubiquitous, you mean this aspect?
Uh-huh.
Yeah. So the location is not of the cloud itself, but the location of person who is using the service. Like this definition is a model for enabling any location. So meaning you can travel to Zimbabwe and still access this service. That's the idea. Doesn't mean that this service has to be anywhere in Zimbabwe. They are not, by the way, not in Zimbabwe. As you can see, they are only in these locations in Singapore and San Francisco, New York, Amsterdam, Singapore, London, Frankfurt, Toronto, and Bangalore. That means they are not anywhere else. This is the limitation, the location that they exist. But you can go anywhere on the planet as long as you have access to the internet, that you can be anywhere. As long as you have access to the network, you can access these locations wherever they provide. Let's go look at a bunch of other providers, by the way. And by the way, you do not have access to these providers, which is fine. But what I have done is, let's go see here. Let's go to this location. And that's where this is a new site, work in progress. But you have access to it. And what you need to do is go look at prepare yourself button right there. And there you will find a bunch of things to do already. Like, for example, download this virtual workstation that I have been playing around with. And then, you set up an account with Amazon Web Services. There is a free coupon available right there. There is a Google account. You can create a Google Cloud Service account. There is a $300 coupon right there. And so you can basically set up account like that. And so there is a Azure account, $200 coupon available, Joint Cloud, another free credit, I don't know how many, some dollars. This guy, DigitalOcean, gives you a $10 credit through that link. This Vultr Cloud gives you, I don't know what, but some free stuff. But they're basically cloud companies. Like Scaleway Cloud doesn't give you anything free. Packet Cloud will not give you anything free. TriStack is completely free. And things like that. The Zoho service is free. Office 365 is free for 30 days. Google G Suite is free for like 14 days. GitHub is free and open source. Bitbucket is also open for free open source. Docker Hub is also open for open source. And Chef account and Ansible account and blah, blah, goes on. It's a whole list.
So
Yes.
Just following on Tina's question, is there any benefit to choosing one region over another?
Yeah, good question. When you say choosing a region, should I choose this or should I choose Singapore or should I choose Toronto? What is the decision-making factor? How would I decide where would I want my machine to be? Okay, how do you answer that question? Like, for example, when I first demonstrated this to you, I just chose the location, San Francisco #2, click. Why did I do that? Because I was being myopic and looking at just me and saying, I am in Seattle and the location closest to me apparently is in San Francisco. So I'm being myopic and saying, San Francisco, give me a machine in San Francisco. And they gave it to me in like a minute. Fine. But that's not how you think. That's not how you should think. So how do you think? Which location should I get? So this is me, or rather you, or rather us. And we happen to be in our Washington state. Fine. The world is bigger than us, right? It's way, way bigger than us. And we will have to identify where is our customer. This customer is where we need to provide them our services. So we need to make sure that our machines that we create are not necessarily in California, but closest to this person. So if this person happens to be in, let's say, Zimbabwe, in that case, I will probably select this location, which is kind of geographically proximity location. But this is like gut response, me telling you for Zimbabwe, I'll choose Frankfurt. That's not how you should actually do. But practically speaking, the distance between Zimbabwe and all these locations, this one is probably geographically the closest. But geography really doesn't matter. in cloud computing, in any computing rather. What matters is the ping time, the response time between this person and the machine, wherever it is. Like, how low can you go? You need to basically test out a setup in which you will create a machine in every possible location and see which is the lowest ping. Lowest time, the most efficient for your customer. And that is the solution, the answer to your question. How do I select my location? Is the one that is best for your customer. That location is what you should select, unless, hold on, there are lots of unless always, unless it's Boeing company, in which case there are laws and regulations that dictate, that require you to be like this and do that and don't go to that country and do this and that. Fine, I understand that. In that case, you find whatever fits into your context, given your rules and regulations. If the law requires you to be in the state of United States of America, then you better be following the law. And so if your customer happens to be in Zimbabwe, you probably take it in the Florida location. I'm just making it up right now. There's no Florida location available here, but maybe New York 3, just saying that. But bottom line is, find out the customer experience, calculate the ping times, calculate the response time, and find the place, the machines which will give you the lowest response time, the quickest access to this customer. Because that customer is who we serve. We serve that customer. We don't serve ourselves by setting up a machine in California. That's a bad way of thinking. Don't do that. Think about the customer and then select the lowest response time, the quickest for this person to get services, access to the services that you provide. That's how you select your location.
Nilesh,
Yes.
Jessica here. So once you select the data center location, you cannot change it though. Originally, if I select London, I assume my customers are European based, but then later I find no, Asian has more customer. How can you change to Singapore? Because it's different data center though.
Mm-hmm. Yeah. So we'll show you live examples. I'll show you live examples of these things. Yeah, live examples. So the question that you have in your back of your mind is, if I set up everything in London, and now you tell me to set up everything in Frankfurt.
Yeah, do I have to request another machine, or I can change my existing machine to move to Frankfurt?
You delete your London machine and create a new machine here.
So all of my data in the London machine will be gone.
Yes.
Okay.
Correct.
Yeah.
However,
Let's back up.
There are some, as we go along, I will give you certain ideas that will collide with the way you think. It will be counter to the way you think. Like you mentioned, data on your machine, right?
Mm-hmm.
That idea is something that I want you to think differently. And I will tell you right now, I'll say this. I will say, don't store data on the machine. I just said that. So that makes, when you imagine, like we'll get to that. We'll imagine, I just said that don't store data on the machine. Okay, then where do you want me to store the data? That's a natural question. But imagine that there is this fictitious place where you store data outside, right? Just imagine. If you store the data outside, you're not really tied to the machine. You can just shoot the machine, like, okay, delete it, bang, gone, done. Because my data is not on the machine, so I can just pick up my gun and boom. By the way, this comes up with a very good example that I would like to give you. What I would like to give you an example of is something that I call, let's go pick it up. Imagine this. You are that's a good example right there. You see that? That's what's going on. You are a cow person, a cowboy, cowgirl, whatever that is. And you are in Texas, right? And you have, 10,000 cows with you. And you are shepherding them. and you are driving them from point A to point B. Like, basically take these 10,000 cows from this location to that location. That's the task. And you are the cow people. You are mounted on horses. You have in one hand the whip, and in the other hand a bottle of whiskey. That's what you get. And you carry a gun with you, right? It's Texas. So you carry a gun. And now you have these cows. And what happens is, out of these cows, one of them is sick. That's one scenario. That's the picture number one. Now let's see other picture. We'll go to Google again. Now we have this puppy. And this puppy is your puppy, for example, right? So this puppy is in your home, and in your family you have this puppy. And so this puppy falls sick. That's another scenario. So imagine if this puppy falls sick, it takes the whole family of the entire family, all the kids will be worried about the puppy, and they'll take it to the vet and take good care and all that good stuff. And that's what they will do. That's natural, right? Expected. However, in this example, you have 10,000 cows. One cow falls sick. What do you think the cowboy in Texas, who's whiskey in one hand and a whip in the other and a gun in the belt, what do you think that cowboy will do?
Kill it.
Yes, that's what happens, right? You know this. They will take the gun, shoot the cow in the head, and move on with 9,999 cows and reach the other end. That's how it goes. That's how life is. So what I'm really telling you is the comparison between a puppy and cattle. This puppy is kind of sort of similar to a machine that you know in your data center. You worry about the machine. You worry about its data. You worry about its location. You worry about how do I take my machine from here to there, or from one design to another design, or one application to another, or migration, or this and that, all those things. You worry about it because it is your puppy, it is your pet. And that's okay. You name the puppy. Like my puppy has a name, Bingo. That's the name of the dog. That's my puppy. And that's fine with it. There's nothing wrong with the puppy idea. So that's the idea that we have, and we are okay with that, and we live like that. Fine. What I'm trying to tell you now is cloud is like cattle, where the machines don't matter. You kill them. You destroy them. Like you saw me destroy a machine right now. You just saw me like that. And that's the idea behind cloud, is that you don't make them your pet. It is cattle. You treat them like cattle. And when you are done with them, you just shoot them. You destroy them and you move on. That's the idea. I want you to think and remember, it's a very, very different idea. This is the way you do things in a data center. In the cloud, you treat your machines like cattle. Remember that. Now we'll do some examples of this.
But how about your data though? I can understand you can move your application from one cloud to another cloud.
I said one thing right early on here. I said, don't store your data on the machine.
But where do you store it when you do the infrastructure service? It comes with the disk space.
Correct.
If you don't store in your IaaS, then how do you integrate your external data service?
Correct. When I say data, you don't put it on the machine, not on the machine. So where do you put it? That's a very logical question. Yes, very logical question. Where do I put my data? Yes, I will answer that. Because without that answer, there is no point in shooting the cow, right? If I shoot the cow, my data is lost. Ouch, that hurts even more. That's not what I want, but I want to shoot the cow. I just effortlessly shoot the cow and not lose my data. That means I have to store my data somewhere else. That is the key thing to remember, is to don't store your data on the machine, store it somewhere else. That's the idea to operate on. And we'll go through examples of where do you store the data. And that's where one of the characteristics that you will see is these compute, storage, and network capabilities, as we'll discuss. These things, we have to treat them as three independent components or ingredients to infrastructure. If you look at infrastructure at a large scale level, don't think like you conventionally do in the context of a data center when you get a machine and you get some disk and you store the data on the disk and then it becomes your pet. That's not how. In fact, many companies will have machines that are named on something that they remember and like. In the case of cloud, we don't want to name our machines. We just give them a random number, like some serial number generated, and just leave it at that. And when we are done with it, we just shoot it and move on. And I think examples will answer this critical question. Okay, then where do I store my data again? That's the question. I understand it. I will answer it through examples.
Thank you.
Through examples. So what I'm saying right now in this preparatory steps, you have to read through that and go through. And if you get stuck, just ask a question. The discussion forum, we have the setup already. I will answer that immediately. But here are the links that I want you to create. Like, for example, click this link, free tier, and it will take you to a free tier location, which will give you free access to Amazon Web Services. And by the way, you're a Boeing company, so you might have access to Amazon already. Don't use that. The reason I say that, at least for the purpose of the bootcamp, is don't use the Boeing account. You have access to Amazon, fine, just leave them alone. Instead, you think like an independent individual who has to then create an entire root level account as Amazon. They're giving you free access for 1 full year. Take it. Every company, most of them, by the way, Google also gives you free access. So just take these free products and use them for a year or so until you get familiarity with what the things that they provide. And I honestly suggest that you take individual personal responsibility accounts, use your credit card yourself with the Amazon company, with the Google and Microsoft and all these things, all these people. Just use your credit card so you will know exactly what it goes when you subscribe to a service from a cloud provider. You don't have to worry about charges on the credit card too much. And I said too much because they're giving you free stuff, like $200. And the machine pricing is kind of dirt cheap. The pricing is $10 per month, or sometimes even less, $5 per month. And that is a month time. The amount of time I just used this machine that I created and destroyed was less than a minute, maybe 2 minutes, maybe 10 minutes, who knows. But the price I'm going to pay is for a full month, I will pay $10 for 1 month. If I translate that pricing to a per hour pricing, it is 0.007 $0.007 I should say this. I cannot I should write it. It is this number per hour. It is too small a number. It is less than 1 cent. Less than 1 cent is what I just spent on that machine. It's very, very tiny amount of money that you spend on such services. And so on top, you have a coupon that is built into the system. So if you don't find the coupon, I think this is a coupon link already. No, not that. Maybe, yeah, this is the credit link is a coupon link. You go through that, they'll give you $10. $10 will last you for like 2 months, roughly speaking. Maybe there is going to be a bill. Maybe you have to spend some money. Maybe spend $1 or $2, but that's the extent of damage. I just want you to be aware of that. By doing this, by doing it yourself, you really understand what does it take to run your own account with a variety of service providers. You will go through not just the technical aspects, but also the business aspects of running through and managing a variety of services in the context of using cloud services. And we have identified coupons for every possible cloud service vendor that we could find, and they're listed there for you. So set up an account. Take responsibility of a billing responsibility, as I call it, which will put you on the gun, basically. The gun is, if you exceed the usage beyond the coupon, they will charge your credit card and you are individually responsible. That's what I'm talking about. So be careful. Don't waste. Be aware of the fact that this is a coupon and not a giveaway to the kingdom for that cloud. So just be aware of the fact they give you lots of freebies. So for example, Google Cloud, $300. Let's see if we can find that. So there it is. So $300 trial. You go click and get $300 for what? For nothing. Just use your Gmail. You get $300 access of Google Cloud. The cloud is cheap. $300 is way too much money. And you try it. Give it a shot. Put your credit card. So you will know exactly the motions of going through these things, because it will give you complete control. If you go through Boeing company, you don't get the complete view of using these services. But again, I say this very, very carefully. You have to be watchful and aware. So don't rush into creating accounts with all these service providers at the same time. Maybe one or two or maybe three, but then stop. Use them. Then take the other ones. Don't jump into rushing into creating a bunch of accounts with a variety of service providers, and then you forget what you have. That's a nightmare. And I don't want you to do that. So just begin with 2 or 3 service providers. Maybe begin with DigitalOcean, Amazon, and Google, and things like that, and just stop. Later on, when you try more, you get other clouds also. Everybody wants to give you free stuff because they want you to use their cloud. That's why they give you free stuff. But with free stuff comes responsibility. Just remember that. Responsibility meaning if you take some resource and you're not using it, you remember to go and delete the resource. Shut it down. Sorry, shut down is the wrong word. I'll clarify. Not just shut down, but actually terminate and destroy. That's the word I want you to remember. You need to go back and terminate and destroy these resources that you took. And at that time, when you actually destroy the resource is when the bill stops. So let's go see the word in another cloud, console, Amazon. I'll go to the Amazon cloud and show you the similar experience right there. Here is Amazon cloud. I'm logged in already. I can go to Amazon EC2, which is where sort of like DigitalOcean you saw. And here you'll probably see this for the first time. Maybe not, maybe yes, but who cares? Launch a new machine. Select Ubuntu. Yeah, there we go. And select the free tier available. Now I don't have free tier available to me, but you have it, or you will have it when you sign up. You have this free tier available. That means you take that machine and it's going to be free to you. So take that machine and you launch the machine and you say that I would like to launch, and you have to provide your key pair, and that key pair is the Nilesh key, and I hope it's the right key, but that's how you launch. And you launch a machine, you get an IP address in like a minute, and you connect to it and you use it and you're done. When you're done, you should come back to the machine and actually destroy the machine. There is also a stop button. So I want to clarify that piece. When you start a machine or create a machine, that's fine. That's when the bill starts. The bill doesn't stop when you stop the machine. You have to actually terminate. And when you terminate, that's when the bill stops. So just remember that. Billing can be stopped when you actually terminate or destroy. Simply stopping the machine doesn't stop the bill. That's the kind of responsibility I want you to be aware of. And don't go crazy on creating machines and then forgetting them. Don't do that, because you will get hit with a bill and you will be responsible for that. So just be aware of that fact and be careful. Start a machine, use it, experiment with it, have party, do whatever you want. Just do experiments, run exercises, run some projects. Ideally stay within the boundaries of the free stuff, and then terminate. This is the most important thing to remember. If you don't destroy, the bill doesn't stop and it will keep on accumulating. And at that time, you will be responsible for paying out of pocket, because the free stuff will be run over by the usage. Extended usage goes beyond free limits. You will be caught. I mean, caught as in you're not doing anything wrong as such. You're just being forgetful. And if you're forgetful, You will be responsible. Just want you to be aware. So my recommendation, although you can create accounts with everybody, just begin with a few, handful. DigitalOcean is my personal favorite. DigitalOcean. I'm not recommending them, but I just seem to like them just because it's easy. Amazon Web Services and Google. Begin with these three. All of them have, this is a $10, this is free for 1 year, and this is, I think, $300 for 1 year. That's the kind of freebie that you have on that website that I showed you somewhere here. No, here. I don't know where. Oh, hold on. What did I do with it? The Cloud Seminar. That's where you will find the Prepare Yourself. That's where you will find the freebie links. And I'll also post a link. So here you list of all these free tools available to you. We'll go through almost every single thing here. Don't worry about it, but just begin somewhere. And this is the beginning point. So DigitalOcean, Amazon, Google. Begin with this. Okay, let's go forward with our definition right there. And 5 essential characteristics. 5. On demand, you got that part. I don't need to describe. Whenever you get in the mood of, open a browser, run a command line, or run a piece of code with an API call, and you get your resource on demand. As long as you have access to a network, that's the second thing here, broad network access. You are expected to use these services via some internet connectivity of some sorts, whether it's internal to the company or outside the company or things of that nature. Broad network access. That's the second characteristic. The third one is resource pooling. In the case of pooling, you're basically sharing resources with other people, with other companies, even with your competition, like the Airbus, for example. Just saying. Not scaring you, but just saying. Sharing. Resource pooling means you're sharing stuff. The next one is rapid elasticity. This elasticity basically means an illusion of what? Of infinity. They want you to believe that cloud is infinite. This is an illusion. No, it is not infinite. We know that. You know that. Most people, at least most reasonable people, understand it. It is not infinite. But what the illusion is, what the idea underneath here is that it will scale rapidly. What does scaling mean? I just said this word, scale. Scale means two things: grow and shrink. Both of these things mean scaling. I think you know that. So that's what I mean by scaling, is to be able to grow and shrink. And by the way, there are two types of scaling. Scaling is of two types. The two types are, let's divide this into two parts. One type is called vertical scaling. The other type is called horizontal scaling. In the vertical scaling, you grow up and shrink down. In other words, you will say scale up and scale down. It's up and down, vertical. In the other type of scaling, the idea is to grow out and to shrink in, out and in. This means scale out and scale back in. Now this, I just wrote on this piece of paper. It doesn't actually describe the idea visually. So I will open another tool and show you what I mean visually. So here is this, hold on, let me adjust it. Here is this machine that I have. Here is another one. So I want to grow out. So what I will do is scale out. So I'll copy them and make more of them. See, I'm growing, and I am growing rapidly. That is what is called growing out, scaling out. Now, if I want to shrink, I will shrink. And this is what is called shrinking in or scaling in. And what is going on is horizontal scale. Grow, shrink. Grow and shrink. You get the idea. Now, the other idea, which is vertical scaling. How do you then shrink and grow vertically? It's very simple. You grow like this or like this. You make a big fat box. That's growth. And you make it small like this, shrinking. This is your vertical scale down. This is scale up. This is scale down. I hope you understand. If you don't understand, I'll explain it again in another context, in another picture. But I think this is important to understand, is that we are talking about two different types of scaling. Vertical, which is what I just showed you with a bigger box and a smaller box. When you grow up and shrink down, it is up and down scaling. It is vertical in nature. And that's one type. When you get to a cloud and you say, I want to get a bigger box, like 192 GB, 32 CPU, 3.75, that's a bigger box. That's $960 per month versus a smaller box, like $5 per month, where I get one CPU and 25 GB disk and one TV transfer. So that's a 1 GB memory machine. It's a small machine. I can grow and go scale up by choosing these machines, like $80 machine or maybe $320 machine. I'm scaling up. I am going even higher and higher. That is my scaling up. And I go scale down and even further down like that. That is scaling down in this cloud. In other clouds, it's also possible. Same thing, just get a bigger box. You get to scale up. You launch an instance and here you select some OS. Let's say select some OS like this one. And here you get to select whether I want to have a 1 CPU machine or would like to get 2 CPU, 4 CPU, 96 CPU, or even bigger. So we can keep growing as we need to. That's the idea of a scaling, scaling up and scaling down concept, vertical scaling. On the other hand, horizontal scaling is very, very simple. It's also very common. This is most commonly deployed. Most commonly used scenario is this, horizontal scaling. What you're doing essentially is looking at the machine you have and then you clone them and get more of them. That is the most dominant usage of scaling, is horizontal scaling out. And this is scaling back in. And you do that all the time. And it is done programmatically. It is done automatically. You don't have to do it by hand. That's the idea. Most of the things that we will do in the program will be automation focused. Everything we will do the first time, we do it the hard way, the difficult way, the really, really, cringe-worthy way, as I will call it. But then the second time I will learn and I will make things and go do extra effort so I can eventually be lazy. Right? That's how I operate. Is if I have something, I will identify what it takes and do the hard way, the really slow way, the manual way, understand every single thing, and then I will write that down in some form of automation tool. We'll use a variety of tools like all over the map. There are tons and tons of tools available in the open source that we can use and we will use. And we will use these to automate our stuff. And the second time I will automate. And the third time I will forget about the thing because it is already taken care of for me. That's how I operate. That's how I would like you to operate also, is the hard way first, and then automate, and then forget. Set it and forget it. It should run by itself. Ideally, that's the case. Most of the time, practically, that's not the case. But ideally, that's the case. Practically, you keep improving things and you keep finding new things and you keep improving your automation and you keep refining your work all along. That's how it goes in real life. So I think you got the idea of scaling out and skin. So back to our definition aspect of the idea that we are discussing essentially is rapid elasticity. That point essentially we are talking about is elastically provisioned and released. You grow and shrink. You grow out and shrink back in, and you scale out and scale in comfortably, effortlessly, and ideally automatically. It says, and in some cases, automatically, to rapidly scale outwards and inwards commensurate with demand. When the demand is higher, you would like to serve more people. So you would like to get more boxes. So when the demand is not high, you shrink the boxes to just one. When you have more customers coming, like these guys, customers, they come and visit your machines. You want to have more, so you get more. How do you get more? You just grow. That's it. It should be done automatically depending on how much load you're facing. So lots of people show up, lots of people visit, you just grow. Lots of customers visit, customers use, you grow the infrastructure. When customers are not that many on your infrastructure, you shrink. The customers reduce, you reduce your infrastructure also. That's how simple the idea essentially is. That's what this definition goes, rapid elasticity. You want to be able to rapidly scale outwards and inwards commensurate with demand, and do that ideally automatically. In some cases, it tells you that, automatically is a better idea, but it's not a requirement. In some cases, automatically. Now, further ahead to the consumer, the capabilities of available for provisioning often appear to be unlimited. Appear to be unlimited. Appearance of infinity, illusion of infinity. That, by the way, is not true in case of DigitalOcean. You can see that. If I go to DigitalOcean and say, can I get a machine in Amsterdam number 2 or San Francisco number 1 or New York number 2? No, because it tells you right there in black colored box. Due to limited availability, we have temporarily disabled this droplet creation in the region. Fine. That violates this idea. Appear to be unlimited. And that's how it is. I mean, does that claim, that they have here is that I cannot provision a new machine in San Francisco number 1 because of limited availability. Does that violate the definition? Maybe not. Maybe it does. I'll let you decide. I don't care about the definition, by the way, too much, unless you haven't figured it by now. This is a definition that some people who are smart, they got together and they wrote this paper. That doesn't make it, like a Bible, if you will. This doesn't dictate your life. Let's not think about this definition as the standard. I mean, it is the standard, but yeah, take it with a pinch of salt. That's how it goes. Like everything in real life, it is actually a old definition. This is like 7 or 8 years old. They have revised it, or they are probably revising it. But definition to me is, okay, I read it, but then I'll do what I like. And that's what you should do, is what you like. So don't tie yourself down with the definition. Take it with a pinch of salt and move on with what you want to do for your customer. So if this definition says often appear to be unlimited, and this cloud doesn't seem to be, That case, so it is not a cloud. That's not the idea, right? Don't stretch the definition too much. I mean, understand it, but then move on to getting things done. That's how I would take the definition with a pinch of salt. And it further reads, can be appropriated in any quantity at any time. Now that is also challengeable. You can go to DigitalOcean and here you say, hey DigitalOcean, can I get in San Francisco, can I please get how many? 10 maximum. I can get only 10 maximum machines. Why? I thought the definition is any quantity, any time, whatever happened to that? I mean, come on, that's how it goes. Real life is different. Now here in Amazon, you say that I would like to get, let's say, configure details of the machines, and I would like to get how many machines? So I'm saying I would like to get number of machines, 99999, like that, some large number. Now if I click this button and actually move through the motions, I will get hit with a large bill. So I'll be an idiot to ask for that many instances. So I will not actually click the button, but just saying that that's what I was talking about. So maybe even 999, I don't know what to do with that many machines. Honestly, I don't know what to do with that many machines. I don't need that many. So back to the definition, it says any quantity, any time, but it has a bottom line impact on your credit card. Doesn't mean that you want to get thousands and thousands of machines for no reason. Of course, unless you're a big company like Boeing, in which case you have a bigger credit card than mine, which is fine. In that case, you might need. So basically, be reasonable, be driven by the needs of the customer, and then whatever machines you need, you get that. But just don't randomly select machines for no reason because the definition says so. I don't think move on. Rapid elasticity, I think you got that point. The last point is very, very important, which is measured service. What does this mean? It means you will get hit with a bill. That's what it means. They're going to measure your usage. They're going to measure your usage of the storage, your processing, your bandwidth, your active connections, active user accounts, every single thing they can do. They will monitor, keep track of, and produce a bill at the end of the day, end of the month. Give you a bill. You have to pay for it. If you don't pay, your service will be disrupted, and they might serve you some claim. I don't know what they do, but bottom line is they are measuring your usage, and you are going to be responsible for the usage. The pricing is published. You enter into a contract with them when you sign up an account, and you are giving them a credit card. Yes, they might give you a coupon or some freebie of $300 or whatever, but they are measuring how much you're using, how much you're consuming. Every single thing is measured. That's what measurement is. At the end of the day, they are going to place a claim on your credit card. That's what they're trying to measure, your usage of resources that you are consuming. So you should make sure that you stop and terminate the usage, and only then they will stop the metering of the service, and then means that the bill will stop. So that's the key things you need to remember are the 5 essential characteristics of cloud computing. Got that? Questions? Are you awake?
Yeah, we're awake. No question.
That's fine. No questions are just fine. It means that, actually, if you don't ask me a question, either I feel really proud of I'm doing a great job, but that may not be the case. Who knows? So you might think that this guy is an idiot, doesn't even stop, goes on. And I am unfortunately guilty of that. I just don't stop unless you stop me. That also translates to me crossing the 7 o'clock hour. I just forget that it is 7 o'clock and I just keep on talking. So if that happens to you or happens to me, you should tell me, hey, it is 7 o'clock, please shut up. You should tell me that. Otherwise, I keep on talking and describing these things because I have so much material that I cannot fit it into the program. It's like 2-month program is too short for it. So
don't worry, we'll let you know if it's past 7.
Definitely. Okay. If you keep on listening, I will keep on talking. So don't worry about that. Now, these characteristics, I think you got that. Let's go move on to the other ideas, right? I want to switch to the 4 deployment models first before the 3 service models. I would like to switch a little bit. So I'll go with this 4 deployment models first because it's easy. So the easy part we want to go focus on is this. There are 4 deployment models. The easy part is the definition of where the cloud is and who is using it. There are 4 different deployment models as according to this definition in this paper, right? There are other ways you can think of and other things that are outside the definition, which is a valid scene. Don't have to question the validity of other claims, but just remember that this is what the definition is, and so fine with it. Just be aware of the fact that this definition is written about 7 years ago or whenever it was, but things have changed in the world. The world has moved on. The definition hasn't moved on. Just be aware of the fact. Having said, let's understand what these things are. Private cloud. Private cloud, an example, a very good example, is the OpenStack deployment that runs inside Boeing Company. That's a private cloud. I have never seen it. You don't want to show it to me, that's fine, because it is your private property. I mean, come on, what are you talking about? Why would I show it to you? No, you will not. So the OpenStack private cloud that you have actually uses open source software called OpenStack, and it is there right here. You have it running in your company. I know because you told me, and actually you have shown it to me also. But having said, this setup that uses the open source software, which is a collection of pieces put together in this website, which is called, collectively known as the OpenStack Cloud, you have this thing running in your company. And nobody from outside the company can actually access it. It is designed just for you, internal usage only. That's a classic definition example of what is known as private cloud. So let's read the definition here. The infrastructure provisioned exclusively used by a single organization, that's Boeing Company, comprising of multiple consumers, like the Boeing Commercial Airplanes division, or this division, or that division, or the Everett people, and the Carolina people, and a bunch of other locations. I don't even know how many locations you have. All these are internal customers. They can use your private cloud. They can, they will, they do. But people outside don't get access to it. It is your private property. That's your private cloud. It will follow these characteristics that we discussed already, meaning it is going to be on demand, meaning inside the company, a Boeing employee can go to some website internally, click a button, boom, gets a machine, connect to it internally, use it, throw it away, discard it, destroy it. And of course, there will be a bill. The bill is internal to the company. It is inter-office bill, whatever you call it. I call it funny money. When you take money from one pocket, put to the other. That's what happens in internal to the company. There's internal billing that happens between the IT service organization and the internal customers. You have such a setup, like most companies, most big companies have it, in which billing will happen, on-demand services will happen, resources are shared among marketing and sales and service and manufacturing and this and that and legal and other people. All of them internal to the company will use the private cloud. Pretty much all these characteristics apply. They also tend to give you this illusion of infinity, which is rapid elasticity, meaning you can scale OpenStack and you can scale it down and you can scale it out and you can scale back in depending on whatever your mood is, literally the mood. The mood is driven by the customer need. And yes, you will get hit with a bill, internal bill called funny money. I hope you understand what a funny money is. In other words, what's the Boeing word for internal billing like that? What do you call it? When one team pays to the other team? Do you have such a thing? I'm sure you do. What do you call it though?
Chargeback? Yeah,
chargeback. Fair enough. Yeah. So one team uses the resources provided by other team, you charge them internal charge back to another team, and they will pay for the the consumption of resource. So that's the idea behind a private cloud, totally private. The other example I would like to now do is a public cloud. You looked at these examples already. DigitalOcean is a public cloud. Anybody and everybody can get an account there, give a credit card, you have the cloud access available to you. Go to Amazon, you get the cloud. You go to Google, and here is Google Cloud available to me. And you can also get an access. And here's my Google Cloud dashboard, and I have a Kubernetes cluster running right there. That's the cluster running right here, which is where we are running all these workloads that you see, all these sites that I have seen, that you're looking at, all these sites that I mentioned in the Slack chat, those things, they run here. These sites are running as various services internal to that setup in that Kubernetes cluster. This we will cover, by the way. Kubernetes is an open source product, which is what I am using right now. We have switched over to Kubernetes from Docker Swarm about 4 months ago. Prior to that, we used to use Docker Swarm, which is another product open source. And prior to Docker Swarm, we used to just be directly with this company called DigitalOcean using machines. These days, I don't use machines. Instead, I use containers. We'll have hands-on exercises on that, a ton of them. Don't worry about the information in terms of exercises. We have a ton of that. But at this moment, I think I want you to focus on concepts. The concepts are in the definition itself. Public cloud essentially means anybody can go in there. It means Airbus can open an account with Amazon and can get allocated a machine in the Amazon cloud right next to you. So when you get these 999 machines for you, Airbus can also request 10,000 machines right next to you, like that. And they might be allocated right alongside to your machines. Who knows? This is public cloud. Anybody can be there, right? That's the concern that you might have. We'll address that. Then the other idea is community cloud. This community cloud, if you read this definition, they have a slightly different interpretation. So we can read that definition. And the idea here is it is exclusive use by a specific community of customers. What does that mean? It means, let's say if you look at the government cloud, which is basically a part of, there is a region dedicated to US government. So this is the GovCloud, as Amazon likes to call it. But what is this? It's a dedicated cloud in which you and I cannot go. We cannot access that because it is dedicated to hosting sensitive regulatory workloads to address the US government security and compliance requirements. It's an example what I would like to classify as a community of people who are consumers from organizations such as the US government. And so only people who belong to the US government can actually access that cloud. And it is dedicated to that community of people. I will call them government people, generally speaking. Everybody in that government agency, in the US government agency, can access to that particular AWS GovCloud, which is here. That's the idea underneath community cloud. You can define your community in any fashion you like. And what I would do is actually define this in my way. So what I do typically is draw a Venn diagram. So if you look at the picture right now, what do you see? You see nothing. That's the entire world. Right? Everybody on the planet. I call them public. So the public can use public clouds. This is the public cloud. Everybody who is a member of the public can use the public cloud. Now in that world, we have the whole world. The whole world is actually the whole paper. As a part of the world, there is this location called the Boeing Company. Is a part of the world. And in that company, you have a private cloud, or I should draw it properly. You have this private cloud here that is accessible to only people in the company, not to the people outside the company. That's how you define the definition between what is public cloud and a private cloud. Sometimes what you will see is there is this hybrid cloud, which is a mix and match of the two. So you have public and private mixed together. When does that happen? It might happen. It might already be happening in your case when you use some portion of the private cloud for certain applications. And then you need more machines and you don't have it because it is kind of limited and you need more. And so in that case, you might want to get access to a larger pool of public cloud from somewhere. And you mix and match your resources between private and public. And that is the idea of hybrid. When you mix and match. Now a scenario like this is very, very common. Let's say if I am the Target store, target.com, and I have my private cloud, a bunch of machines running here in my location, and this is my private setup. And I know that this setup is not enough for me to survive the onslaught of customers that start to accumulate as I progress my year, January, February, March, April, like that, October, November, December, September. And as the year progresses, I know my needs are kind of stable, but then suddenly this thing happens called Black Friday. And the demand starts to grow. And sometime around December timeframe, the holiday season kicks in and the demand is really high. And then the things go back to normal. That's how a typical situation that I will find if I am target.com. My retail usage of my services will peak around Christmas timeframe and is kind of steadily growing beyond what I can actually tolerate. My infrastructure can handle only this much in the private capability, is only this much. And so what do I do now when I have September, October, November, and December going? What do I do? Should I spend more money and build my own private cloud? Should I know I have capacity of this much and I have my needs kind of low in January and February, but comes September, October, November, December, I will have more need. So I will have to plan for that. So what I can do is spend like $20 million and spend that money up front and build a bunch of machines right there. So I grow my capacity. And then, my usage is very low again, kind of hovering here. And I spend $20 million for no reason. And I'm wasting this much. Underused. Underuse is waste. Now here, I know my demand is going to grow because it is season. The target.com website will get hit with people buying stuff. And so here is, this segment is not underused, but unmet need. My customers are unhappy if I cannot service them. The needs are not met. Here, my boss is unhappy because I'm wasting my money. And here, my customers are unhappy because I am not able to service them. So I have a problem to solve. What do I do? Don't want to waste money. Don't want to spend $20 million. Waste is bad. And also, I want to make my customers happy. So this unmet need is also a bad idea. So what do I do? That's the question. That's where a public cloud will come in handy. What you should be able to do is to burst into public cloud. This bursting will allow you to use the resources available in the public cloud for the duration of time you need it, and then back in business like usual. Now, this is a hard one to pull together, and yes, we will get to that point. But I want you to understand that that's the scenario of usage when you will see a usage of hybrid cloud in practice. That's what this idea of hybrid cloud comes into play. It means it's a composition of two or more distinct cloud infrastructures, whether it is private or community or public, mix and match, that remain unique entities but are bound together by standardized and proprietary technology, standardized or proprietary technology, or that enables data and application portability, or cloud bursting for load balancing between clouds. That's the scenario. So that's the concept of deployment models.
So Nilesh?
Yes.
So at some point, we're going to mention a little bit about security in this kind of model. I mean, I know the public, is it entirely open or is still security type of thing could apply in there?
Yeah. I'll tell you about security. In fact, we have a lesson for you to read about security. Let me identify that lesson location. Where is that? I think I have too many tabs open, so let me just shut some of them. Let me get to the point where I can quickly get to the security aspect of the idea that you want to read. I want you to read ahead in this section starting from here, and I'll give you a link. In this section, you can read more about how do you isolate yourself from let's say, the Airbus company, right? You want to use the public cloud, but you want to remain secure. You want to keep your data safe. You want to keep your applications different and distinctly different from anybody else. Don't let them come in. How do you protect yourself? You will create something known as virtual private cloud. It may not be real like your OpenStack deployment inside your company, but it is going to be private. It's going to be virtual private cloud. It is going to be a separate dedicated area just for you, but not inside your company, physically not in the building, be away from you. We'll create that kind of a setup. VPC. This idea of a VPC is what Amazon Web Services uses this name, virtual private cloud. Other companies like Google will use the name virtual private network. And Microsoft will use another name. I think they use the name virtual network. So basically the same thing. It is the same thing that they provide you. It's an isolated area, private, dedicated to you, but it's going to be still using the public infrastructure, VPC. And there is an exercise for that. That exercise is the link that I just pasted in Slack chat. By the way, I want you to remember that this Slack chat thing is something that you want to copy from here and keep that in some kind of a notebook for yourself. We'll post a ton of things here. And so it's a good idea to just go to that location, which is going to persist. This location is the discuss location. Like that location will persist. This Slack chat will disappear. So if you post anything here in terms of a new topic that you want to create by clicking the new topic button and type, that will persist. It doesn't go away. Slack chat dies eventually. And that is something that Slack is more like a chat channel for us to quickly exchange some links. Like I just pasted that link there. So you can click on that link, but you want to keep track of this, maybe make a OneNote notebook or something of that nature where you can keep track of these things for yourself and as you take notes for your own consumption. This is a video that is, I think, about 28 seconds.
You want to take a large number of applications.
Okay, shut up. Yeah, I shut him up. But this guy is going to walk you through little short videos, like a 2 minute, 1 minute, and maybe there is a 7 minute long video that describes you the concept of VPC. And there is an intense hands-on exercise that is, if you do it the first time, it is going to be mind-boggling. I'm just alerting you already ahead of time. This one is too much. But yeah, just go through it. You will understand it. So that's why this is probably the what I call the hard way approach, the difficult way of doing things. This is it. When you set things up by hand, every single thing by clicking some mouse buttons in a web browser. That's what this thing is, to step by step understand what does it take to build your own virtual private cloud. That's what the answer to your question about security is, what I'm answering. Is that this thing that you should read ahead. And by the way, you have access, you should read ahead. Don't wait for me to cover it. You have access, so that's the reason I gave you access, is that you can go read ahead as fast as you can. Don't wait for me. Because there is just too much content and too little time. So if you like something, you consume it, you read it, go do it. If you get stuck on doing something, ping me. Open that question on that Discuss website and I will answer it immediately. If you need something like right now and right then and there, just call me on the phone or Slack chat. Slack is the best. I live right on these tools, so I just answer immediately. Having said, let's go resume our discussion on that definition right there. So we discussed private, community, public, and hybrid, those 4 types of deployment models. How do you deploy cloud services in these three or 4 models? That's the concept according to this definition. Newer discussions on the internet, you will find other people discuss different things. That's okay. I mean, that's not wrong, but this is what this definition says. So fine. This is the standard, by the way, in our country. So we'll follow the standard. Fine. Moving on. The next idea I want to talk about is the 3 service models. This is where most of the rest of the cloud technologies will focus on primarily, is on that idea of 3 service models. And these things are software as a service, platform as a service, infrastructure as a service. We'll understand that in great level of detail, but at the top, we'll begin with just mentioning these things in a picture that looks like what I will draw now. So if you know computers, like most of us do, you know that these computers are manufactured mostly in Taiwan and China. You know that as a fact. Whether it is Dell, HP, IBM, or Apple, or any other thing that you buy, some piece of hardware, it is basically made in China. Just understand that. That's how even cloud infrastructure is made in China. So who makes it? At the foundation, there are these things that are called, CPU, which is made by Intel or AMD. And then they put together what is called a reference design through the CPUs that in my laptop, I have Intel Core i7 CPU. That's the CPU that is made by Intel. They also give you a reference design to use on the motherboard. And companies like Asus and a bunch of other manufacturers of motherboards will manufacture these boards. And they are all based in Taiwan. They make those motherboards which will host the CPU and memory and other things and the cards and all that. That goes into the construction of a machine. So what I would like to call these guys as underlying component providers, right? They provide components. And at some point, you will put these components together to construct what I call a box or a computer. for short. Box is my preferred term, box. So in that box, you will have compute, storage, and network capability primarily. So you get these boxes and you rack them up in form of a stack that you saw in a picture, in the data center picture that we saw before somewhere in Google, right? You saw you know what a data center looks like. That's what these boxes are meant for. Rack them up, like a box looks like pizza box, and you rack them up like on top of each other, and you construct a rack of boxes. That's essentially is how infrastructure is built from bottom up. So now if you look at all this setup, you are basically looking at the foundation. You have CPU makers, then you have motherboard manufacturers, then you have people who make reference designs put together, and then these reference designs are then used to create boxes. Then people like Dell and HP and IBM will put their sticker and call it a Dell machine or HP machine or things of that nature. So basically it's a sticker that they put on top. The actual boxes are made by Quanta, Compal, or ASUS. There are a bunch of other manufacturers in Taiwan and China that makes those boxes based on the reference design created by the manufacturers of CPUs. And you get to a point where you have some sticker people. Dell will come and put a sticker on some Compal box and say, this is a Dell server. Fine, I get that. And that's their contribution, is basically a sticker most of the time. Maybe I'm extending this and pushing it a little bit too much. Dell has also smart people, but I'm just saying. So you get to a box and you put them in a rack, and that becomes your infrastructure at the foundation, that you put those racks and racks together in a building that becomes your data center. And that data center is what you need to now slice and dice and divide into smaller virtual machines and then serve to other people, like we saw in the DigitalOcean example. You saw me use this cloud. Where is that? Oh, DigitalOcean. DigitalOcean. You saw me do that, right? I just go there and log in and get a machine as simply as clicking a button, and I get a machine allocated to me. I use it, connect it, throw it away, discard it, destroy it, and I'm done. And I have accumulated a bill. How much bill did I get? 1 cent. That's my current usage. Fine. So I pay for it and move on. Having said, what we are looking at is the layer at the bottom is how you're trying to build what is generally known as infrastructure as a service. In that infrastructure layer, what we are really receiving as a consumer are storage, network, and compute capabilities in form of configurable things. Like you saw here, I can configure to have a particular operating system loaded, like FreeBSD or Fedora or Debian or CentOS. You will notice that Windows is missing, but that's okay. Because 90% of the cloud is mostly Linux, so they don't bother about Windows, but other clouds do. So you can get Windows in other locations, not in DigitalOcean. Just understand that. They don't give it. Fine. So you choose the OS, and then you choose the size. And that's a classic infrastructure as a service provider. What they're giving you is the underlying infrastructure. Whatever under the hood, you just hide it. I don't need to worry about whether it's Quanta machine or Compal machine or Dell machine or what motherboard or what CPU. Don't even have to worry about it. All I care about is give me some CPU and some memory and some disk and some network capabilities, and I just use the machine. That's where I will run my applications on, and that's what I am really worried about when I'm using infrastructure as a service. And so you saw one example of this. There's another example of another cloud, Vultr Cloud. I don't even know if that's the right way to say this name, Vultr, but that's the name of the company. And I'm going to log in and I'm going to show you, and it kind of sort of looks the same way, like DigitalOcean. You go here and click to deploy a new machine, and you select there are more locations here. So Miami and Seattle and Tokyo temporarily sold out. See, Tokyo sold out completely. And Seattle So I can select my Seattle location, and then I select CoreOS, and then I can select machine type. There'll be some noise, I think, I suspect, because my dog is going to bark now in a minute because somebody rang the bell. So if he barks, I'm sorry for that. I'll mute if needed. I think he's quiet today. But you get to select the machine infrastructure. And similarly in other clouds, you go to console.google cloud, and you will find the same setup. In here, you will find you get to create a VM, pretty much similar to what you saw before, create an instance. And here you can find that you can create an instance in any location. So you can select, say, my machine. I give it a random name, and then I select a zone. The location I want it to be US Central 1A, West, Europe, and Asia, and like that. And they have some South America locations and North America locations also, Australia location. So you can select a location you like. I tend to prefer the location nearest to my customer, which is where most of my customers are. So it is the Seattle area. That's where most of our customers are. And so we select US West 1A. Here we get to select the amount of CPU we need. So I can select 1 CPU or 2 CPU like that, or maybe 96 CPUs. And then I can further select the operating system that I want. And here I say that I want to get Ubuntu, or maybe Red Hat Linux 7, or Windows Server is available these days. Windows Server Core is available. We have also the older version of Windows Server available. So you can select whatever you want, and you can also choose the type of disk you want to get, whether SSD or regular disk. You can choose SSD if you like. It's going to be slightly more expensive. And here you can choose how big a disk you want. You can choose as big as disk as possible, like 65536. So it's 64 terabytes of disk. And then you cancel out from here, and then you say that I would like to create that machine. That's how an infrastructure service provider is classically in this example. What you're looking at also, which is kind of unique to Google's services, is what you will now see when I do it, is that they don't bind you to these limits. Like whatever sizes that they have available in most clouds, you will find the same setup. Here in DigitalOcean, you get what you get. So they'll give you these choices, and you get to pick and choose the standard droplets or optimized droplets. That's the choice. You don't get to further customize. Either you get this or you not get that, or you get something else. That's the choice you make, and that's what you have. Whereas in case of this cloud, it's different. Let's see how it is different. This is infrastructure as a service discussion. We are looking at infrastructure, and here we can customize. And you can pick and choose how many cores you want, and select how much memory you want according to what your need is, and whether you want to further extend the memory, and also select the CPU type, whether you want to Skylake or Broadwell or later. So Skylake or Broadwell platforms on the Intel Core, you can select that, which generation. You can also further go and select GPUs for cryptocurrency processing, Bitcoin mining, or other types of computations that are necessary where you need a GPU. You can also select how many GPUs you want. In that zone that I am currently in, GPUs are not available. I need to go and change the zone to some other location, like US Central, I think has it. In that US Central 1A, you will find GPU selection. And here I can select that I would like to get 8 NVIDIA Tesla GPUs in my machine. So I can do some cryptocurrency mining if needed, and accordingly fine tune the number of cores and number of memory that I have. And I will be billed according to what I am configuring. So it's very, very highly configurable. And right now it is telling me that my effective monthly bill will be, hourly rate will be $3.4. and a monthly rate will be $2,904 for this machine that I just selected. Only one machine with 96 CPUs, 624 GB of memory, and the NVIDIA Tesla as the GPU. I select 8 GPUs, for example, only on certain CPU platforms. Okay. Only on certain, so there are certain limits here. You can see that it is available to only on certain platforms. So what platform is available? So choosing a machine type, and you have to do some research on exactly which combinations you can get a GPU or not, and then select that. Only then you will be able to receive that GPU. I think I have to shrink this down to make it available automatic, and then you should be able to select a GPU right there. And now I have a total monthly bill of this one box of about $3,393 per month, an hourly rate of $4.6 per hour. And if I click, I will get a machine with 64 CPUs, 240 GB RAM, and 8 NVIDIA graphics card included, with Debian operating system running, and connected to the network. And I can further allow other aspects to it. We'll go through the other aspects later on. But right now, that's what you're looking at from a infrastructure as a service perspective, is you get to pick and choose. There are other aspects to it. For example, in other clouds, you will see Amazon machine type, they have a different word for it. Let's go see Amazon instance. There'll be a sheet coming up in Amazon that will give you they call it EC2 instance types. So here you will see the same idea that you saw in Google's case, the same idea, but in Amazon's language, the same concept described in Amazon's way of talking, is the idea of a T2 machine. This is the cheapest possible machine you can get. And this is the one you get for free, for the free tier, 1 year free usage, T2. This is just one CPU, excuse me. This T2 micro machine is T2 Nano, actually, T2 Nano. That machine is one CPU. I think T2 micro is also free, not just Nano, but micro is also free for 1 year. So you can get these machines for free and run them. So that's the smallest size. That's not how production workloads run. In real life, you will run something at least like a M5 on a medium or a large machine to begin with. So there are these machine classifications that Amazon has: M5 large, M5 extra large, M5 2 times extra large, 4 extra large, 12 extra large, and like that. That's the classification types in terms of general purpose machines known as the M machines. Now you can get to the other types of machines like compute optimized. And here the machine type classification becomes C, Charlie, C as in Charlie 5. What you're looking at is the focus is on high CPU count. Since they don't have the flexible ability to let you pick and choose the number of CPUs they have, they are classified themselves into machines that are optimized for computation or optimized for memory usage. So in large memory requirements, if you have them on a given application, you can select the X1 classification. And there you can see whether you will get a large memory of 3,904 gigabytes of memory. This is RAM, by the way, I'm talking about RAM. So very, very large amount of RAM, roughly about 4 terabytes of RAM. Is it 4? Yes, 4 terabytes of RAM and 128 CPUs. So it's an extra memory, optimized memory machine. Whereas here you will see the storage optimized machines is the H1 class. And here you see that the disk size is very, very big. The memory may not be as big, but the storage is really 2 terabytes each. So you can even get bigger disks. If you need more disk, you can get more disk. You just have to get an H1 type machine. There are other types of machines also. For example, accelerated computing, P3 type. So there are these NVIDIA GPU included. So NVIDIA Tesla V100 GPUs included. These are the accelerated computing, which are your general purpose GPUs included in the hardware. That's the way that Amazon likes to describe their infrastructure available. And Microsoft also has similar naming. So you can see Microsoft machine types, Azure machine types. What do they call it? So here are the Azure classifications. You can see that in general purpose, they have B type, DSV3 type, DV type, DSV2, DV2. It is confusing. It is confusing. But what I would like you to take away from this discussion is that these names do not matter. What really matters is the application that you're running. And more importantly, the customers that you are dealing with. So these customers, they matter the most. Then you have to understand what are the workload they are putting on your infrastructure, and then identify what kind of setup do you actually need for your application to successfully service your customer. And then you come up with a requirement set of a classic machine type that is ideal for you, for your customer, for your application. And then you take it back to these cloud companies. Hey, what's the closest approximation to what I have in mind for my usage? Can you tell me, Azure, what do I have if I need a machine that is this much RAM, this much CPU? Can you find the closest match? That's how you go and find a corresponding match. And it turns out that you might need some kind of a high performance A8 machine type. Then that's the answer. And then you take that answer and compare that back to other cloud companies. You go back here and say, hey, I need 32 CPUs. So I'd say select 32 exactly like that. And I need that much memory is good enough. Yeah, I don't need that much memory. I'll say, 120 GB, maybe, that's good enough memory for me. So that's my need. And now I will know my pricing already right there. My pricing is going to be this much. I can very, very easily quickly tell the number of cores and the number of memory I need for my application. I can get a quick idea about the pricing. That's the beauty of this Google implementation, is that it lets you pick and choose and fine tune in a very, very granular fashion. Pick and choose the quantity you need, and they don't dictate you necessarily in terms of what you have in terms of limited choices that appear to be there in the basic view. In the basic view, you get to choose what they give you, but that's not the idea. You can always customize and then decide what you need and then pick and choose appropriately.
So, Nilesh,
Yes.
I thought IIS does not include operating system, but if you scroll down the Google here, it looks like you have option to choose Linux.
Correct.
So I thought that's platform as service. With that's operating system is go with platform as service. You mean like the DigitalOcean, when you create a droplet, it does not ask you what kind of operating system do you want.
It does.
What? It does?
Yeah.
So OS goes with IIS or platform path?
Yeah, I know what you're asking. So let me describe the answer. In your mind, you're thinking that operating system is a software.
Mm-hmm.
And
it's a middleware.
Yeah, it's software, right? It is software, middleware. And infrastructure is hardware. So why are you putting this operating system in this bucket? Why is the line is here? The line is here. Why are you putting the operating system software in the IaaS discussion? Why? Good question, good point. And I'm not questioning your thinking. All I'm saying is that is what it is. That's how these clouds are set up, is to make it easy for you to pick and choose what operating system you like to have. So if I want to say Debian, then I get Debian, so I don't have to do the extra work. That's how they have set up. There is one cloud, by the way, that lets you select which thing you need, and you can boot from whatever operating system you like. They will give you just the machine, no OS. I will show you that example also. Right there. In this cloud called Vultr, you can go to the account and then create a new machine in which you can select to boot from an ISO that you upload from a location. And then when you use your ISO, that is going to load up an operating system onto a machine that you are going to select Pretty much like that. So you create a new box and you say, I want it in Seattle. And then you say that, you know what, I don't want to use any of these operating systems because that's not what I want. But you know what, at the end of the day, you will have to run some OS somewhere. So that's fine. You can upload your own operating system. It can be basic, bare minimum bootable thing that will let you connect to it. Like a tiny piece of Windows or Linux kernel, whatever you want to run, something so that you can actually interact with the hardware. You need some software to be running on the box in order for you to do a connection. That network connection, of SSH connection that we just saw in a demonstration in the early example with DigitalOcean, are connected to the cloud. You need some software to be running on the other end. So you have to upload the ISO or provide a custom PXE script, which is going to be a PXE boot. You know PXE as in, let's show you the PXE part. PXE
yeah,
boot.
I got it. Yeah,
you got the PXE part,
yeah,
right?
I got it.
Okay.
It comes with something to boot up the machine. Then
Correct.
you can, then the customer can replace the OS.
Bingo, exactly. So
okay,
you either provide a PXE boot like that, or you provide an ISO, and then you get to the machine part. That is also possible. Now, what I'm saying is that this crossing a boundary, OS not hardware. Why are you crossing into the application in the infrastructure area? Good point, but don't stress too much into the definitions of it. Think in terms of usage. Think in terms of what is relevant to you. And don't stress about the definition aspects, because at the end of the day, it is just a piece of paper. Who cares about it? I don't. This is a definition document. Where is that? Where did it go? That piece of paper I've been reading, is that document? Just a piece of paper. Do I care about it? Not really. I mean, yeah, I use it. I spent 3 hours talking about it, but I don't really care about it, because what I care about is my application and my customers, and I want to make them happy, and I'm going to run whatever I want, and I want to do it easily. So either I would like to use an OS that they give you, like Debian, and select, and I'm done, or I can choose my own ISO, upload it, or use a PXE. All those methods are possible. Now, this PXE method and ISO methods are not available in every cloud. Some clouds do provide that, others don't. Like in other clouds, you will not find it. But don't stress on the idea of crossing boundaries as to what happens when operating system is a middleware piece and you're pushing it into the infrastructure area. Violation. It's not really violation from a definition perspective. Yes, it is, but who cares? I mean, you should not be caring too much about it, but it's a valid point. You draw the boundary here and you notice that there is a crossing of boundaries and you questioned it. Good point. I like it. Moving on. Where did the definition piece go?
Can we wrap up?
Oh, we crossed the time. Okay, we'll continue. So what I will do is now I'll stop the recording and I will create this recording will get processed and it will show up in the website in Cloud Genius Cloud Technologies location in the recorded video section in the Cloud Technologies. And we will resume the infrastructure as a service, platform as a service, software as a service discussion going forward in the next session. We will be meeting again on this day, which is March 28th at 4 o'clock Pacific time. We'll discuss cloud technologies, and we will show the video will show up right here in the Spring section. That's where it should show up in a few hours from now. I'm pasting that link for you in Slack chat. So you should know where the link is right there. That's where the video will pop up. It'll show up right here. It'll take about 3 to 4 hours to process, and then it'll appear here. And with that, I will now stop recording, and I'm open for questions.